Hey guys, and welcome back to a very long new video. In this video, we will build a full Compose Multiplatform contacts list app. So we can now finally build a full app with just one single code base in Kotlin and Jetpack Compose, which will work on both iOS and Android. So if you've been thinking to learn such a technology to build apps for both iOS and Android for a while, then please do yourself a favor and watch this till the end. I know this is a very long video, but these are really the videos that will help you the most. Of course, it also helps to watch videos about these single pieces, but then you still don't know how to put all these together in a functional app, how to structure the architecture of that app, and just have an impression of how to approach such a bigger app. So if you want to learn this technology, Compose Multiplatform and KMM, and you don't watch this till the end, then I really can't help you. I mean, I could make this a paid course. This easily took a full work week full of preparation and recording and editing, but I decided to make it a free video on YouTube, also just as a thank you to you to just give something back, because all of you have been so loyal to my channel for such a long time. The channel has been consistently growing over the past years. So I also want to have videos on my channel for those of you who might not be in a situation where you can easily afford one of my more advanced paid courses. And maybe a question some of you will now have is, do you need a Mac to follow this? Because initially, when we wanted to build KMM apps, so with Kotlin Multiplatform Mobile, then we just needed that Mac because we needed to write Swift code. So Swift is the programming language we use for iOS development, for native iOS, and that sadly only runs on a Mac. However, now, since we have Compose Multiplatform, we have pretty much our whole code base in Kotlin. And that has a pretty big advantage, and that is that also if you're using Windows, you can fully follow through this video. What you can do on Windows is actually run the iOS app, because that requires a simulator from iOS. But if you are just a native Android developer and you want to learn how to build such a contacts list app, potentially also with KMM, then you can follow this exactly the same as people with a Mac can, just that you can't run it on iOS. So let's now take a look at the app that we will actually build. This will not only be a plain contacts list app, but actually a Material 3 contacts list app. So it will support things like dynamic colors, it will support dark mode, and use all the new Material 3 composables. So you can see on the left side, this is our Android app. On the right side, this is our iOS app. They look exactly the same since we share the UI with Compose. And since we share the UI, we also need a way to share view models. So if that is new to you in KMM, then you will also learn how you can do that and just have one single view model for both Android and iOS. Then, as you can see, this app also supports selecting and saving photos. So each contact could have an optional photo, some don't, then it will just display such an avatar image. But if we want to add a contact here and click on this floating action button, then this little Add Contact Sheet will open up. Here we can select a photo, one of these, let's select that one. And you can see we have the contact photo. We can give it a name, test, some sample phone number, and a sample email address like this. And if we then hit save, boom, there's our new contact. It gets added to the recently added category. So we also see a history of our added contacts. And I intentionally added this functionality to add a photo here to contacts, since that requires native functionality, because the local file system obviously works differently on Android than it does on iOS. So we kind of need to implement a solution that works for both. So photos will be saved just as normal files on the local file system, and then we have a local database implemented with SQL which will be used to just save the additional data like the first, last name, phone number, and email address. And last but not least, you will learn how I would recommend to manage dependency injection on multi-platform projects, since here we don't have access to libraries like Dagger Hilt. And maybe to also quickly show you dark theme and dynamic colors, what that actually is, if you're maybe new to Material 3. That's basically just a new way of new UI guidelines when we use these material components, which will adapt the look and feel of your app to your wallpaper. And you can see that my Android app has different colors than the iOS app. This one here is in green colors, while this one has, purplish kind of colors. So to make that work, we just need to define a base color scheme, which is this green here on iOS, because on iOS we can't use dynamic colors. So that is just something that is integrated into the Android platform, but not yet on iOS. But I also guess that won't happen since it's not from Google. But on Android, this will actually adjust based on the wallpaper we choose. So you can also see here, we also have these adjusted colors. But if we now go back to our home screen, you can see my home screen wallpaper is purple. And if we change that, wallpaper and style, and we then click change wallpaper, And then we just choose something, maybe here from this art category, maybe this orange like wallpaper here. If we select that, wait a little moment, then make sure that's applied for home and lock screen. A little bit laggy here. Home and lock screens, select that. And this is now our wallpaper. And if we now go back to our app, and this is super laggy here on Android, the iOS simulator is working much better, but doesn't matter. If we now go back to the app, you will see it adjusts to our new colors. And I will need to create a new emulator here, but I will do that in a moment. You can see we now have an orange color theme. Yes, it's okay. And also if we switch to dark mode, let's toggle this on. Also takes a little moment. This is so laggy. And there you go. So you can see we also have a dark theme, which is now adjusted to the user's wallpaper. If we click here, we have these adjusted colors. So on Android, these dynamic colors are quite cool, and I will show you how you need to actually adjust your theme in order to make this work and look well. And just before we finally get started with building the app, there is currently a summer sale ongoing for all my paid courses on my website. So if you've been enjoying my free videos and you want to take this a step further and just build more advanced apps, for example, also a KMM app, which really uses the native UI. This is the Compose UI, which of course doesn't feel that native anymore on the iOS side. But I also have a more advanced Android premium course about KMM, where you learn how to do exactly that with a cool translator app. If that sounds good to you or some other courses are interesting for you, check the first link in this video's description and make sure to apply the discount code SUMMER25 during checkout to get them for less. And in order to get started, you need to pull the initial code from my GitHub, because that makes sure that you have the exact same version combination that I use for all the dependencies, that you already have the setup that you need for Compose Multiplatform, and that you already have the initial color theme set up. Of course, I will show you how you can set up your own color theme, and then I will explain how you can create that. But since Compose Multiplatform is currently in alpha, it might be that if you watch this video at a later point and just use the most up-to-date version of Compose Multiplatform, that things might not work out in the way I show you here. So that is why I really recommend you to choose the exact same versions that I do. So just pull the initial code from GitHub to just make sure it will work right away. If you want to learn how to set up such a Compose Multiplatform app for your own apps, then I have a different video which I already created. I will link it somewhere up here. But if you just want to learn how to build such an app, then just watch this video for now. You don't need to know this exact setup yet. So here on GitHub, you will also find this link in this video's description. You can simply go to code, copy this HTTPS URL here, and then go to Android Studio, go to File, New, Project from Version Control, and then you simply paste this URL here. Of course, you need your GitHub account linked, but then you simply pull this into your Android Studio with a single click on clone. And to get started with this, I want to explain the dependencies we will use first. So just the libraries we need to use, which ones we use, why we use exactly these. Then I will go through the theme. So the initial colors that I have set up, I will show you how you can create your own theme and how I have created these colors. And then we finally get started with writing some code. So right here, I am in our build-up Gradle shared file, which contains all the shared dependencies that we share between iOS and Android. So that is how that is structured. If you're new to KMM, then you should definitely watch my KMM setup video. So you need the KMM Android Studio plugin in order to make that work. I will also link that somewhere up here. But if you already know how to create such an empty KMM project, then we basically have an Android module here, which is nothing else than an Android app. You already know that from pure native Android project. And we have such a shared module, which contains Android main, common main, and iOS main. I will get into the details here in this video for sure, but in the end, this shared module contains the code we want to share between iOS and Android. And in this app, this is pretty much all the code our app has. So there's still some platform-specific things like image picking and saving images, which is why we have this Android main and iOS main directory, but really most of the code will go into common main. And really just to show you how little Swift code we need to write, this is the full app in Xcode, so in Swift. We just need the single compose view, which we need to create, and this is how it looks like. All the other code will be written in Kotlin. Let's go through the dependencies we need to use here. The start is not so interesting here, but what is interesting is this common main variable here, which contains dependencies. And apart from the compose dependencies, which we directly add from the Compose Multiplatform plugin, so you just need to make sure that you have this plugin here and you can add these dependencies. So we use material 3, obviously. We use the extended icons, so we have more icons to be used in our app. We use the Compose resources, so we can also deal with things like displaying images in composables in the shared code. And then we have some custom dependencies. On the one hand, SQLDelete, which is our local database solution, which is purely written in Kotlin, so we can share that between iOS and Android. We have Kotlin X Datetime. That is just a Kotlin version of the datetime library, which we have in Java, to get things like the current timestamp in milliseconds, to just deal with the dates and add days, add hours, and just do some date math. Then if we scroll down, we have a specific set of dependencies for Android main, so just pure Android dependencies. On the one hand, we need an Android driver from SQLDelete, we need the app compat dependency, and we need activity compose for image picking. Then for iOS main, we just have the SQL native driver, which we need there. And if we scroll down, we have an additional set of dependencies down here, which we need to specify here. And that is Moco. That stands for Modern Kotlin, and is a set of libraries that is specialized on making Kotlin multi-platform nicer and easier. And this library will make it very easy to share things like a view model. It will make it easy to use flows and also have these flow collectors in Jetpack Compose, so that we can collect the flow as compose state, because that of course works a bit differently since we're now dealing with Compose Multiplatform, and these things also need to work on iOS. But that's pretty much it in regards to dependencies. We also have some extra stuff in our Gradle file, but here we really just specify the plugins we have, so our Compose plugin again, and yeah, what else? We have a Gradle file in our Android module, which doesn't really have more stuff. This really looks like a normal Gradle file from a normal native Android project. It also was generated that way. I just made some very minor adjustments like the JVM version and stuff like that, and also added the Compose plugin, but here we really don't need to change much. And now coming to the color theme. How did I create that? So first of all, when you want to create a Material 3 color theme, you need a base color. So basically a color your app will be in if dynamic colors are not supported, because those are only supported, I think, from Android 13 onwards. And before that, you just need a fixed color theme, which won't change depending on your user's wallpaper. And for that, you can use the Material 3 builder from Google. So just go to this URL here. I will also link that in the description. And here you can really just insert a single color, and this generator will generate all the other theme colors for you, which is of course super helpful. So here on the left for core colors, I want to click on primary, and then we can choose our primary color. And depending on that primary color, the material calculator will calculate all other colors that your app needs so that it looks well. So you can see if we move this here, then the colors will automatically change. And you can of course choose your very own color theme here. I will choose my brand green color, of course, which I think is this color code. Yes, that is my brand color. And if I now click close, then you can see how that looks like. So it automatically generated all the other colors. If we scroll down, this is how the Material 3 components would look like. You can also enter something here, so you can see how it looks like when text fields are focused, how progress indicators look like, how these chips look like, how buttons look like. And down here are the actual colors that you need to now copy and paste in your Android project. That takes a little moment because you need to copy every single color individually, which is a little bit annoying. I wish they would have just generated some code so we can just paste the Kotlin code and paste it in our project. Sadly, that doesn't seem to be the case yet. So just copy these and paste these as Compose colors exactly like that in your code. I already did this for you, so if you pull the project, you already have these. Take a look in Android Studio and go in Shared, Common Main, UI, Color. Then here you see our whole theme colors. So I just pasted these color codes here as Compose colors for light theme, and the same for dark theme. So quite a lot of colors, but now we can work with that and define our theme, which is here. So we have a dark color scheme. We just assign exactly these colors for primary, secondary, tertiary, and so on. And we do the same for our light color scheme. And then I will show you in Compose code how we can now have that final theme wrapper, which also worked for Compose Multiplatform. And I would say we start writing our first piece of code, and that will just be the core of our app. That will be the contact model. So in our common main module, in this root package here, we want to create another directory called contacts for a contact feature. We just have one single feature here, but inside that we will have presentation, domain, and data folders or packages. We want to put our model in domain, of course, since that's where our core models belong. Create that, and in here we have our contact. That will be a data class. And now we need to think about what kind of data a specific contact needs to be displayed. On the one hand, obviously an ID. That is what we use to save it in our database later on and to uniquely identify a contact. We then need a first name, a last name. We need an email address, and we need a phone number. And now we also, of course, want to be able to save a photo, an optional photo with each contact. How do we do that, or how do we save that in Kotlin Multiplatform? I would recommend to just use a normal byte array here, so photo bytes, for example, which is a nullable byte array, since that is just a pure Kotlin data type that can be used to represent a photo. You can't use things like a bitmap here because those are only specific to Android, and we can't make these work in the iOS module thing. So we have the JetBrains bitmap, but not the Android one. I will show you how we also make use of bitmap to show these later on. But here for this actual model, we want to keep this as isolated as possible. So we just use the pure Kotlin data types. And RStudio complains a little bit here because we should generate equals and hashcode functions. Since then it will also compare the contents of our byte array. But let's just leave this here. This will generate some weird stuff, as you can see here. I will just leave this because we don't really need to compare two contacts. And if we don't need to do this, then we don't need to worry about that. So now that we have our contact model, what comes next? First of all, I would like to start with building the core UI. So I will leave out the recently added section yet. And start with a normal contact list so that we can already check very early if it works on iOS and Android by just using some dummy data. And for that, I would like to go into our contacts folder and create a presentation package for all of our UI related stuff. And in here, I will create a contact list state. And that will be a data class that just summarizes all the values that could change and have an impact on our contact list screen's UI. So what kind of data do we need here, or what kind of state? On the one hand, of course, our contacts list, which is just a list of contact. Initially an empty list. We want to have our recently added contacts, which is also just a list of contacts. We want to have a variable for the selected contact, which is a nullable contact and null by default. So as soon as we click on a contact, we assign the contact we clicked onto this state, so we can show the contact detail sheet with all its details. We then want to have a state whether the is AddContactSheet open, just a boolean and false initially. So if we click on our floating action button and this AddContactSheet opens, then we toggle this to false. And we also want to have the same for is contact details open is equal to false. Well, let's actually call it is selected contact sheet open to just have some consistency here in naming. And we then finally want to have a first name error, which is a nullable string. So in case the validation fails for the first name field, then we want to show specific string there. And we want to have the same for the other types of fields. So last name error, we have email error, and we have phone number error. Like this. The only thing that's now missing is the values or the states of the text fields of a new contact, but we will make that a separate compose only state because entering text fields in a flow or managing that with a flow and reactivity can lead to some problems, which I will talk about later. But for now, this is the full state we need for our screen. Next up, I want to define an event class. That will be a sealed interface actually, and there we will define all the things, all the UI actions the user could potentially do on the screen. So every single thing, like clicking on the floating action button to add a contact, or dismissing the contact sheet, or just deleting a contact. So all these things will be one single event. Because then we can just say, hey, that is our action that the user just clicked on that button, for example. We send that to our view model to handle it there and update our state accordingly. For that, we go to presentation, create a new interface, which will be called ContactListEvent. Select sealed interface, and in here we specify all the different events the user could potentially send from the UI to the view model. On the one hand, that will be actually object, which will be called onAddNewContact. Click. When the user clicks on add contact, we send that to our view model. when the user dismisses that, we also want to send that dismiss contact. This will be used for both the selected contact sheet and the add contact sheet. So we just dismiss all sheets that are currently open. Then we need events to change the contents of a text field. So on first name changed with the new value contact list event. Duplicate that 3 more times. Do the same for a last name. This one for email. And this one for the phone number, like this. Then next, a data class when the photo was changed. So on photo picked, we can pass a byte array, just byte array, also contact list event. And let's just make that a normal class so it doesn't complain here. We again don't care about comparing these events, so they don't have to be data classes. We then need an event in form of an object when we click on the photo, so when we want to add a photo. So on add photo clicked, contact list event. We have an event when we want to save the contact. When we hit save, contact list event. We have an event, a data class, when we select a contact, like this. So when we click on a contact to see its details, contact list event. We have the same for editing a contact, so edit contact, valid contact is contact, and contact list event. And last but not least, we have one for deleting a contact. This doesn't need any argument, or it doesn't need the contact to be deleted, because we can only click this button to delete the contact when we already have the selected contact sheet open. So in the app, when we click on this contact here, for example, then here's our delete button. And then we already know which contact is to be deleted because that's open. So if we click this here, then you can see it will directly disappear. Okay, so now we have all the things the user could potentially do on our contact list screen, which is also the only screen in our app. We have the state. We have the state here to also make sure, or to also know which values could have an impact on our screen's UI. And I would say we start writing a component, a composable, for the contact's photo. So here, if you take a look on iOS, the photo would just be this component here. If there is no photo for that contact, we just display this little box in material 3 colors with this icon. And if there is a photo, we obviously display it. And this component will not only be used here and here, but also if we select a contact, then here this photo component will also be used to also show this in larger. So how does that now work? How do we now create a composable? We do it the same way as we did on Android previously. We just go to presentation in this case, create a components package where we will put all of our single UI components, which we use on our screen and which are reusable. And here we create a new content file called contact photo, normal file. And in here we can now create normal composables just the way we do that on Android. It's super cool. So we call that contact photo. Here we want to pass the contact that we want to show the photo for, which could be nullable here. We want to pass a modifier, which is the default modifier. And we want to pass an icon size. So how large this contact icon would be if there is no specific photo, which would be a dp size equal to 25 dp by default. Alt enter to import that. And as you can see, there is no real difference to normal Compose. However, in a moment, you will notice a difference. Because if we now go ahead and we just say, okay, we check if the contact.photoByte is not null. So if there is a photo to be displayed. And we then use an image composable. Well, we have a painter, an image vector, and an image bitmap. Obviously, we don't have the option to directly display a byte array. We also don't have that in native Android and native Compose. But that is now a bit different because normally what we would do is we would read in that byte array as an Android bitmap and then convert that to Compose bitmap. We can't do that here because we're not in an Android project and we don't have access to that Android-specific bitmap. So we need a solution that works for both Android and iOS. And that is now where these Android main and iOS main modules come into play. Because if we have code we want to use in our shared module, but the implementation of that code differs based on the platform, based on Android or iOS, then we can specify the code itself inside of common main, so kind of an abstraction of it, and write the implementations once in Android main and once in iOS main. And that is actually the case for displaying such a bitmap or converting a byte array to a bitmap, because that works a bit different on iOS than it does on Android. Let's take a look at how that actually works. So in our root package in common main, we create a core package, which is just for shared stuff that could potentially be interesting for multiple features. We only have one feature here, but I don't see this utility function we create here fit into our contacts feature. So core presentation, and inside there, we create a file called bitmap-util. Just a normal file. And now what we'll create is a so-called expect function. Expect is a keyword that is only for KMM projects, or Kotlin multi-platform projects at least. And here we call this remember bitmap from bytes. We pass our bytes array, which is a nullable byte array, and we then return an image bitmap, which is now from Compose. That is what we can use in our shared section of the composable, but the conversion needs to happen on each platform individually. And I will show you what this expect means in a moment. We just want to annotate this with composable to make sure this needs to be a composable function. And now this expect is comparable to an abstract class or abstract function. With expect, we specify we want to have this function, but the implementations, the actual implementations, belong in Android main and iOS main. And it currently complains because there is no such implementation of this function, which we can change now. So going to Android main, we want to create our same package structure here, core.presentation. And inside there, we also create a bitmap-util file, select file, and here we now have our composable function, which is now the actual function. So the actual implementation of this expect function needs to be called exactly the same. Remember bitmap from bytes. We have our byte array, call it the same, and we return a nullable image bitmap from Compose. And in this Android main module, we now have access to all the Android specific code because this is specific for Android. And here we can also make use of the normal Android bitmaps. And it's still complaining here, okay, because yeah, that is not nullable. This image bitmap should be nullable, of course. If the byte array is null, we also return a nullable bitmap. And here we just return remember, or from Compose, remember with our bytes. So whenever our bytes change, we also want to change the bitmap that is returned. And if these bytes are now not null, we just return bitmap factory, which is now the function that wouldn't be available in the shared module. And we say decode byte array, which is our bytes. Our offset is 0, and our length is bytes.size. That is now a normal Android-specific bitmap, and we want that as an image bitmap, which works for our shared section as well. So we convert that as an image bitmap, so it will work just fine. Else, we just return null. And now we have the Android-specific implementation, so the code or the shared section will use this implementation if the app runs on Android, and it will use the iOS implementation, which we specify now, if the device is running on iOS. So let's actually take this bitmap-util file, copy this, scroll down to our iOS main folder now, where we also have just Kotlin code, but that is now an iOS-specific implementation. We create our core/presentation, and here we now paste our bitmap-util. Yes, just continue. We will fix this. We will remove this because bitmap factory is not available here in this iOS main folder now, since that's an Android concept, an Android function. And instead, Compose Multiplatform comes with another helper function, which is now only available for iOS, which we can access with bitmap from JetBrains here, .makefromImage. And here we pass an image.makefrom encoded. And here we can then pass our bytes. Then we call as compose image bitmap. And now when I'm thinking about it, it might actually work to put this in the shared code, because I think there is no reason why this wouldn't be available in the shared code. We could also quickly try this out, but then you already learned about this concept, which we will need later in this video as well. So if we just take this code and put it in here without actual and without this one here, then this should actually work just fine. So we have access to these functions. I'm sorry for that. Just notice that very spontaneously, but I guess that should work. So we now have one single shared remember function, but you already learned about this concept with expect actual. So we can also remove this bitmap-util from Android again and from iOS, since we don't need that, it seems. I thought this was only available for iOS, but it seems like that's not the case. Let's now make use of this function for our contact photo. So val bitmap is equal to remember bitmap from bytes, and we pass our contact image.photoBytes. And then we also want to have a photo modifier, since that differs, that is actually the same, for our two different cases we have here. So if we don't display a photo, the shape of the composable we display is the same as if we display a photo. So that is just modifier.clip, and we clip it to a rounded corner shape with 35% rounding. And if now our photo bitmap, or just our bitmap here, is not null, we display an image that takes in that bitmap. So bitmap, content description is just contact.firstname, for example. Then the modifier is modifier, actually our photo modifier, nothing else. And finally, we want to have our content scale and set that to crop, so that we always crop these images so they fit into our squared shape. If that's not the case, we don't have the bitmap, then we want to show this thing instead. No, actually not this thing, but rather what we have on iOS here. So this would be the alternative we would display, which also shows up here in a little bit smaller. For that, we just use a box modifier dot, actually just photo modifier, and here we also want to add a background color, which now comes from our material theme. So material theme, color scheme, and for that I just use secondary container. When it comes to choosing the right colors for the right composables, I'm usually trying around a little bit, but you can see these are the colors, and I then take a look at what the builder here is showing me, and then think about what would look well for this component that I'm building here. So in this case, for this little contacts icon, and if I scroll down, then usually the primary container would be a little bit too prominent. So this green here, which is for the fab, the floating action button. So that would be used if you really want to highlight an action. But for such rather secondary things, I would use the secondary container. And if you then want to show another type of container, which maybe has a different use case, you can then use the tertiary container, and it will all look well. Going back to Render Studio, we'll make sure that the content alignment is set to center here. So we just center our icon we show here, and then we just have our icon. The image vector will be icons dot rounded dot person. That's the icon I want to show here. Content description, again, just contact dot first name. Modifier is modifier dot size with our past icon size. And the tint also now needs to fit to our container. That is just material theme dot color scheme on secondary container, because that is now the color that is displayed on this secondary container color. And then it will look exactly like this. So these two fit together perfectly well. And that is our very first shared Compose component in Compose Multiplatform. What I think doesn't work yet is the preview for such shared composables, since it's still in alpha. At least I didn't find anything in regards to that because it's so new. So I sadly can't show you yet how that looks like, but you will of course see it the first time when we launch our app later on. The next component we are going to build is the contact list item. So in the end, just one row here of our contacts list to display a contact and also be able to click on it and things like that. So let's get started and implement this contact list item in our components package. Contact lists item, make that a file, composable contact list item. What does that need to display a contact? In the end, it just needs our contact object, and it also needs an optional modifier, which we set to the default modifier. And in the end, this item is very simple. It's just a row that displays our contact photo we implemented previously, and a simple text next to that with a contact's first and last name. So let's have a row. This one here, the modifier is simply modifier, and our vertical alignment will be center. And here we need to specify that with alignment.center vertically. In here, inside of that row, we first of all want to have our contact photo. The contact is just our contact we passed here. The modifier is modifier.size 50 dp. So that is just the size that I think looks good. And then I want to have a little bit of spacing. So we have a spacer with a width of 16 dp. And then we have our text that displays the contact's first and last name. So text will be contact.firstname space and contact.lastname. Here we want to assign a modifier as well and just say that text will fill the remaining width of our row. Okay, now that we have the composables for displaying such a photo and such a contact item, we can start to implement this contact list screen. We will leave out this recently added section for now, as I said, but we can already implement this list here and the floating action button. So in our presentation package, outside of the components package, we're going to create the contact list screen. Will also just be a composable called contact list screen. This will, on the one hand, just receive our state, so it can properly display its UI components based on that. It will also have a new contact, which is a nullable contact. I will get to later why I didn't include this in this state. I teased it a little bit already, but it's pretty much just the contact we're about to add. And we want an on-event lambda, which we will now use with a contact list event. And with that single lambda, we can now send such events up to the parent composable of this, where we will host the view model, which will then, however, receive these events, which we send with this lambda. And the view model can then process these, update the state, which will then be passed down again and update our UI. So as a root for this contact list screen, I want to have a scaffold. And this is really the same as with normal Compose in Android. We just use this in this case to display a floating action button at the right position. Here we can just create that floating action button. We have an on-click lambda. When we click that, we want to call our on-event lambda with contact list event dot on add new contact. Click. I want to give it a rounded corner shape of 20 dp, rounded corner shape 20 dp. Alt enter to import dp. And then we want to specify some content for that floating action button. Let's also already put the parentheses here, the curly braces, to get rid of this error. And in here for the floating action button, that content will just be an icon. The image vector will be icons dot rounded dot person at. So just this specific icon here that fits pretty well for a contact list app. And the content description will be add contact. And for such material, 3 components, such as this floating action button, these will usually already take care of using the right theme colors for this. So in this case, we don't need to explicitly specify the colors, since the Material 3 guidelines already cover that, which component should use which specific theme color for what kind of surface. And for floating action buttons, that is just the primary container one, so this little prominent green color, and then on primary container for the icon tint. We need to add a little experimental annotation here for scaffold. Also, that is nothing new in Android. So let's go inside of the scaffold. What do we now want to have here? In the end, the scaffold hosts nothing else than just a lazy column. So let's create that. The modifier will be modifier.fillMaxSize. We then want to add some content padding of padding values 16 dp, and we want to have some vertical arrangement of arrangement that's spaced by 16 dp. So that will just make sure that there is 16 dp of space between each item inside of this lazy column. And now we want to start with creating this my contacts text here. So we will simply have a normal item, and in that we will have a text. The text will be my contacts, and then followed by our state.contacts.size. So however many contacts we have. And this should actually go inside of parentheses. The count of that. Then we will assign a modifier to this text, which will be modifier fillmax width. And I want to add some horizontal padding, horizontal of 16 dp. And then let's make sure the font is in bold. And then we can go on with some more items. This time we have an items block. Let's choose this import that takes in a list, because here we now want to show all of our contacts. We then get a reference to each contact, which we can now use to display such a contact list item re-implemented previously. So let's create that contact list. Oops, what did I do now? Go back to contact screen. We want to have a contact list item, pass in our contact that we're currently looping over, and the modifier will be modifier.fillMaxWidth. we want this item to be clickable. In that case, we would want to send an on event with the contact list event dot, what is that? When we click on an item, we want to select a contact and we pass this contact we are about to select. And then we also want to add some horizontal padding of 16 dp. And I think for this padding values up here, I only want this to be for the vertical padding. So let's add this. This will just achieve that when we scroll here, which is currently not possible, that the scroll container won't be cut off here, but the text will actually go to the very top edge of our screen, but still the padding is applied here. So here is 16 dp of spacing. And now I would actually like to try this out to also show you that this is already working, but this composable, this contact list screen isn't used anywhere. And obviously, we also didn't really set up our theme yet. So usually in Android, if we take a look here in our Android-specific app, then instead of the set content function, we have something like, in this case, maybe a contacts theme, which is a wrapper that just makes sure that we can access these theme variables and values wherever we want in our project. But in Compose Multiplatform, this doesn't work at least as easily as it does on Android. So what we need to do is we need to go to core presentation instead of our common main module, and we want to create something called a contacts theme. Will just be a plain file. And here we will make use of this expect function again, which I showed you previously, but we didn't need this previously. This time we really need it. So an expect function called contacts theme. And this now takes some variables or parameters rather. On the one hand, we want to be able to pass whether the device is in dark theme or not. We want to be able to pass whether we want to use dynamic colors so that the theme colors are adjusted based on the user's wallpaper. And we want to pass some content, which is our actual screen. Like this, so just a composable lambda. And why do we now make this an expect function? Well, because the implementation of this differs on Android compared to iOS. Because on Android, we use dynamic colors, which are directly natively supported. But to create that theme for that, we, for example, need access to the Android context, which we obviously don't have on iOS. So we need two different versions of this theme wrapper. So taking this context theme file, copying that, and going to core presentation instead of Android main, let's implement the Android-specific implementation of that. I'll paste that here. We want to swap this out with an actual function. And now that is that needs to be a composable function. So let's annotate this here and here as well. And now here we have access to all the Android-specific functions, variables, classes like contacts, for example. And in here, we really just do what Android Studio would generate for us when we create a new Material 3 project. On the one hand, we want to define the color scheme we want to use. We can do that with one expression, because if dynamic color is enabled and build.version.stdkint is larger than or equal to build.versioncodes.s, because that is the Android version from which dynamic color is supported. So we're going to just make sure that this is the case. And obviously, this version check is also very Android specific. Because on iOS, we don't have these SDK versions. On iOS, we also have versions, but they work differently compared to Android. So in this case, if we want to use dynamic colors and dynamic colors are supported, we want to get a reference to the context, which you can also now easily do since we are on Android, local context.current, and we return, if dark theme is enabled, then we say dynamic dark color scheme with our context. That is a function that will now automatically create the color scheme depending on the user's wallpaper if it's in dark mode, but if not, we will use a light color scheme, dynamic light color scheme, passing in the context as well. If that's not the case, so if either we don't want dynamic colors to be enabled or they're not supported, then we want to check, okay, is at least dark theme enabled for that device? Because then we want to use our base color theme, so the green theme I showed you in the material editor, and we want to show that in dark theme. Then we just refer to our dark color scheme, which we created here in our common main theme file. So this will be the dark color theme and the light one. And these will also be used for iOS since we don't have dynamic colors there. And else, so if dynamic colors are not supported or not used, and we're also not on dark theme, that means we're just on light theme, so we can use light color scheme. Like this. So now we already know which color scheme to apply for Android. The next thing is something Android Studio will also automatically generate here. That is just a little helper to adjust the color of the status bar as well, based on your theme. First of all, I want to get a local view for that current. And if we are not in edit mode, if view.is in edit mode, so if we're not inside of the layout inspector in this case, then we'll have a side effect. So this block will now run after every successful recomposition. We want to get the window from our contexts. We can get that from the view.contexts as activity, that window. So we just get the window reference from the activity itself, because with that we can then change the color of our status bar. So we can say window status bar color is equal to color scheme dot primary, so our primary color that to ARGB. So we just convert that to a color that we then apply to our status bar. So that way we also just make the status bar color support dynamic colors. And something I want to do is window compat dot set, actually get insets controller, where we pass our window and our view, and then we call that is appearance light status bars, and we set that to whether we are in dark theme or not. So this will just make sure that if we have a dark toolbar, we have the light icons on it, and if we have a light toolbar, we have dark icons on it, which makes sense because then there's a lot of contrast. And yeah, that's pretty much it. We now only need to call the actual material theme, so material theme, which is a normal composable. And here we can say we have a color scheme which we want to pass. Color scheme, we want to pass our typography, so which font we use, which we just specified here. So this purple variant, which we specified in our command main directory as well. We're just using the default font, and our content is just content. So now we have the Android-specific implementation of this theme wrapper. On iOS, we now need to do the same, but it's super simple. We actually only need this last block on iOS because iOS simply doesn't support these dynamic colors yet. So going down to iOS main, core presentation, we want to create our contacts theme here as well. New file, and we can just take this function from command main and paste it here in iOS main, make that an actual function, and actually have the implementation here. So this time we just directly create the material theme. And the color theme, or color scheme in this case, is just if dark theme is enabled, we choose our dark color scheme, which we specified in our theme file, and else our light color scheme. Then for typography, we do the same. So we have our typography from our theme folder, and for the content, that also remains the same. And boom, that's our iOS specific variant here, which simply does not support dynamic colors. We still need this parameter here. Otherwise, it would complain if we have this parameter here, but not in the iOS specific variant. And now what we need is just one single wrapper that is a composable function, which applies this context theme depending on which platform we are. And this will be the composable we will call both in our Android main activity here and in our iOS code later on. And for that, let's go to our command main, root package, create a file called app. That will be a composable function, also called app. And here we're going to pass whether we are in dark theme or not, because how we retrieve that value, what the current theme is also something that just differs on Android and iOS. Same for dynamic color, whether that's enabled or not. And then in here, we're going to use our contacts theme, passing our dark theme value and our dynamic color value. And then this is our wrapper where this theme is now applied. Then in here, let's have a surface, a material one, so that the background color is also adjusted. Modifier would be modifier.fillMax size. And the color of that surface, let's import modifier, I'll enter. The color of that surface would be material, theme, color scheme, that background. So just our background color. And then here in the surface, we can finally create our contact list screen, which now needs a state. Where do we get that from? Well, we could just create a dummy state here with some dummy data. That is what I will do, but I will still create a view model before where I will put that state in. We won't implement the functionality of that view model yet, but just to have it and to show you how we can get an instance of that in our shared module. So in shared contacts presentation, new file called ContactListViewModel. Make that a class, and you will notice that we have a view model import here, which does not come from Android because we can't use Android-specific view models in the shared module of KMM projects, since the iOS side wouldn't know what to do with these. So that is why we use Moco, Model Kotlin, the library that makes it very easy to share view models, since it has a very similar import here, which is called the same. And that allows us to just have a normal view model here as we know it in Android. And we can also use that on iOS. It just does some optimizations and changes behind the scenes so that iOS still knows what to do with this view model, but it hides these from us so that for us, this is really the same as for Android. And in here, I will just create a state, the same way we do it on Android, mutable state flow off, and we create our contact list state. Like this, we then have a public immutable state, which is just state as stateflow for now. And I want to have a var for our new contact, which is a nullable contact. And we say that it's just a mutable state off. So by mutable state off, null initially. I'll enter to import that. So that is used to change the contact whenever we click on add contact. This will be just a very empty contact. And whenever we then change the first name, for example, we update the first name of that contact to represent that in our UI. It's a separate field because of the text field issues I mentioned. I will go through that later again. But this way, we already effectively have a real view model. And I want to pass some dummy data in here. So let's just do it down here. We have a private val, just some basic contacts, which is a list of. And in here, we can initialize some contacts. We can also do this with a loop, by the way, a little bit easier. So let's say 1 to 50. Let's create 50 dummy contacts. And we say map and create a contact for each. So the ID could just be it.toLong. First name could be first it. Last name could be last it. Email could be test@test$it.com. And we have our phone number, which is just, 1, 2, 3, 4, 5, 6, 7, 8, 9. Our photo bytes, we can't create these here yet as dummy data, so let's just keep these as null. And then we say here our initial contacts are just that, those contacts we create here. So just that we have some data to display. So in our app file, above this surface, we now want to create that view model instance. And in normal Android, we would just get that with either view model or Hild view model, if you're using Dagger Hild. But with Moco, so with the Moco specific view model, we use a get view model. That works a bit different compared to the normal view model composable. Here we need to pass in a key, which just identifies that view model. So it's basically just the screen this is attached to. So we can say contact list screen. And we have a factory, which is just a view model factory. We can use the lambda for that, in which we create an instance of that. So if our view model has constructor arguments, we can also pass these here, but right now it doesn't. We still need this factory. So we say ContactListViewModel and just create an empty instance of that. With this view model, we can now say we have our state, which is equal to view model, actually by viewModel.state.collectState. And that is the exact same as for real Android. So we also have this collectState function, but this time it again, actually it doesn't come from Moco. So this is the real function that just converts a flow into compose state here. But now we can take this state and pass it here to our screen. We then want to pass our new contact, which is viewModel.newContact, and our onEvent lambda is just viewModel::onEvent. We need to create that in our view model. So let's just have an empty lambda here that takes in events of type ContactListEvent and doesn't do anything yet. The error goes away, and you can see how clean that now is. So we have our app wrapper, we have our theme wrapper, which applies the theme. Here we then have our view model at the root level, so we don't need to pollute our actual screen with that view model, which would couple it to that view model, which would be quite bad and harm UI testing and also things like the preview, which doesn't work yet for Compose Multiplatform, but I guess in future they will also add such functionality. And now, if we take this app composable, scroll up to our main activity, and just call this here, then we can pass whether we are in dark theme. On Android, that's really easy. We just say is system in dark theme, and dynamic color will just be true, since we want to use dynamic colors. And if we now launch this, I hope we should be able to see something on our device. Great, it will probably take a little moment to build this initially and now. And I am getting an issue. It looks like I forgot to remove that platform class. Let's click here to locate where that is and just remove it, because that is just created initially by KMM or by an Android Studio, but we don't need that. And I removed it in the shared package, but it seems like not in the iOS main and Android main one. So let's run this again and take a look. Okay, it seems we still got an error, and I remember that there was a reason that I put this in iOS main, which I spontaneously did not do here. I'm very sorry for that, but it seems like we need to put this back in iOS main, since this AskCompose image bitmap seems to only be available in the iOS main module. For some reason, we can still access it here, but it will give us this error. So let's take this, or rather, let's just copy this function signature here, paste it above, make that an expect function, and then have this function in iOS main. So let's remove this, go to iOS main, presentation, paste it here, make sure that you have the actual keyword. Always takes a little moment until it enables syntax highlighting. Here we can also optimize the imports. And here, a little moment. Then we need to import all these values. On the one hand, composable, image bitmap, remember, Alt enter on each, bitmap and image from JetBrains. And last but not least, also AskCompose image bitmap. And then we do the same for Android with the same stuff I showed you before. Let's just go through this very quickly. Paste it in Android main. You already know how that works. This time, composable import, image bitmap import, remember import. Just this thing here, how we get the bitmap differs. Here we say bitmap factory, decode byte array. We pass in our bytes, pass in 0, and bytes.size. And then we say as image bitmap. And now we have an actual function for Android and an actual function for iOS. So this should hopefully work. This function is still called in contact photo if we take a look. So that shouldn't change anything. Let's rerun this on Android and take a look. Hopefully now we don't get any errors anymore. And it works. You can see here is our list of 50 contacts. It also displays that we have 50 contacts. We have our cool floating action button. And if we toggle our theme, we should also see that we have this in light theme as well. If we switch our background to something else, and then we hopefully also see that our dynamic colors are changing. So here, wallpaper and style, takes a little moment, change wallpaper. Let's take something like, I don't know, solid colors would be easy. Let's choose something dark and see how that would look like. Just something black. I'm actually not sure how dynamic colors handles this. Set this for home and lock screen. There we go. Let's take a look at how it would look like in our app. Right here. And will it adjust that? Okay, it seems like it's very similar to what we had before. It's a little bit brighter, this red here, but we can very easily test this if we also go back to our app, not that app, actually main activity, and disable dynamic colors, because then it will use our green color theme. If we relaunch this, as you can see, it immediately adjusted that. We don't even need to relaunch it, and it also supports dark mode, of course. Cool. And that now works on Android. But what about making it work on iOS? Since this app thing here is still a composable function, and iOS in Swift doesn't really know composable functions. So how do we make it work? To make that work, JetBrains and KMM actually came up with a so-called view controller. Those are the things that show something to the user on iOS, and that view controller allows this interoperability between Compose and iOS in this case. And to create that, that's very easy. We just scroll down to iOS main. Let's go to the root package, and we call that main view controller. Make it a normal file, and that will just be a normal function, main view controller. And we set that equal to main view controller. Actually, compose main view controller. For some reason, it doesn't show that yet. Or is it compose UI view controller? I'm sorry. And here we now get a function. And guess what? This is now a composable function. So that is how, the bridge between iOS UI and Compose now works. In here, we can call composables. So that means we can also use our app composable. Well, how do we now know whether we are on dark theme or not on iOS? We can already tell that the dynamic colors are disabled, so we set that to false. But on iOS, we also have a dark and light theme, so we should at least support that. We can easily check that by having a val is a dark theme, and that is equal to UI screen, this one here, dot main screen, dot trait collection, dot user interface style, and if that's equal to UI user interface style dot dark, this one here, like this, then we know the device is in dark theme, and this is now pretty much Swift code, but adopted to Kotlin. So that is just something that comes with KMM, so that we can still use the Swift code and write iOS specific code inside of our iOS main directory, but it's pretty much just Kotlin and Kotlin syntax. So I like to still use the Swift code in here in iOS main, but we could also specify this directly in Xcode later on, but I don't like that. So then we can take this as dark theme and call it here, or pass it down. And now we need to take this and call it in Xcode. That is really the only thing that we need to do in Xcode itself, where we build iOS apps with. How do we get to Xcode? Well, we need to scroll up to this iOS contacts MP, and here we have an Xcode project. This is the file that needs to be opened in Xcode, so that just contains the project information. We can open this by right-clicking, open in Xcode. Then this will open up here. And in content view, that is just the Xcode specific, the initial code of Xcode. We'll remove this greeting because our project doesn't have this greeting class anymore. But you will see we have a shared import, so we can now access our shared code here directly in iOS. And all we want to call now in this content view is a compose view, which we need to create, but that's simple. I think I showed you that before in this video. But to make that work, we simply need to go to our root package here, new file, Swift file, we call that compose view, like this. And here we want to paste this code. I went through this code in a little bit more detail in the video where I showed how to set up KMM Compose Multiplatform projects, but I don't think it has a lot of relevance here for this course specifically, which is why I just pasted. So all that really happens here is we create such a controller for iOS so that we can actually call this in our Swift UI view here. And that just calls our main view controller from Kotlin, that main view controller. So that refers to the file, that refers to the actual function, which then contains our compose code. You see it complains because there's no such module shared. We can try to still launch it. Sometimes it works, sometimes it doesn't. If it doesn't, we need to rebuild our Android Studio project. First of all, select an appropriate iOS simulator. I will use iPhone 14 Pro. Launch this here, and maybe it immediately gives us an error, but maybe also not. It's building, and I hopefully see you back when that is finished or through an error. And that seems like the build was successful. It is currently launching here on my iOS simulator. And there it is. We have our Compose Multiplatform iOS app as well. Our scrolling works. You will notice sometimes it's a little bit laggy. That is something I noticed as well when building this, especially later when we also have some animations. This isn't running super fluently on iOS yet, which I think is because KMM Compose Multiplatform is still in alpha. And I hope they will improve that. But I think it's already quite impressive that we are able to write UI code for both platforms in Kotlin. That is super cool. Now we have a working sample of our contacts list app. But what is next? Of course, we're not done yet. I would say the next thing we implement is our actual database, so that we can really store and read contacts persistently. And then we will implement our view model logic, so we can actually read these contacts from our database and also handle all the state updates, so that when something happens, when we click on a contact, when we click on our fab, that actually something happens on the screen. When that is done, we will implement the image picking and image saving on both platforms. And when that is done, we will implement the recently added contact section on top. And then we are pretty much done with this project, but still there is quite a bit to do. So let's better not waste any more time and jump back to Android Studio, where we want to implement our SQLDelite database. To get started with SQLDelite, we first want to go into our build.gradle file in our shared module, this one here. And here we need to configure that SQLDelite plugin, which is already added here, as you can see. Let's do that right here by having an SQLDelite block, this one here, to configure that plugin. And the way SQLDelite works is it will just generate the necessary classes behind the scenes. So the Gradle plugin will do that. And we just specify the raw SQL queries once in an SQ file, which the Gradle plugin then, however, will interpret and create the classes for us. And here in the SQLDelite block, we want to specify that we have a database. How it's called? Well, it's called ContactDataSource. And we need a package name for the generated classes, which I will choose com.plcoding.contacts compose multiplatform for .database. So just my package name followed by database. And we want to set the source folders to a list of, list of, and called SQLDelite. That is just how I will call the folder in which I put the SQ file, so the raw queries. We can then synchronize this. Hopefully we don't get any errors. And where do we now define this SQ file? Well, for that we go into command main, right-click new directory. We call that SQLDelite. So that is the folder the plugin will now look for, since we specified it here. And inside that, I will have a separate database folder. And here, if you don't have the SQLDelite plugin for Android Studio, you first need to get that. Otherwise, you won't have syntax highlighting for that. So by going to the Android Studio preferences, you can go to plugins. And you need to make sure that you have this, SQLDelite, this plugin here from Square, because then you can also easily create these files. If you have that from the marketplace here, you can then go to SQLDelite database, right-click new SQLDelite file or table. We want to call that contact, so that is just our whole database. And then here, we on the one hand specify how our table looks like, and then we define the different queries we want to access our database. So we only have a single table here, which is our contact entity. How does a contact look like? Well, first of all, it consists of an ID, which is an integer. It's not nullable, and it's our primary key, and we want to auto-increment it. That is just how SQL works. So if that's new to you, then better watch an SQL course. This would be a bit too much for this video to also cover every detail of SQL, but it should be pretty self-explanatory. We then want to have a first name property, which is a text and not nullable. Same for last name. Then we have the phone number, text not null. We have email, text not null. We want to store a created at timestamp, which is an integer not null. We need that in order to sort our contacts based on when they have been inserted, to also get the recently added contacts later on. And we're going to have an image path, which is just a text, but nullable. Since we won't store the images for each contact in the database itself, which you could do, you could just store a byte array in a database, but that really is against performance, because then every single contact entry in your database could be really large due to that saved byte array. And that can just make queries more inefficient. So what we will do instead is we will save the image on the real file system of the device and then just save the path, so the reference to it, where we can find it and where we can read it into memory again. And I'm missing a comma here, and then the syntax will also be fine. After creating this table, we now define the different queries we need. On the one hand, we want to have a query to get all contacts, and here we just say, hey, we want to select all columns from the contacts table from contact entity, and we want to order that by the first name ascending. Cool, and that is how we define the queries in SQLDelete. It's pretty simple. Then we also want to have a query for getting the recent contacts. Again, getting all columns from contact entity. This time we order by created at. Ascending, actually no, descending for this one, since the largest timestamp will be the contact that we added the most recently. And since we only want to get a limited number of recent contacts, we want to call limit with the amount. So by using colon here, we make sure that the Gradle plugin from SQLDelete will just make that a parameter of our function. So we can specify how many of the recent contacts we want. If we pass 10, then we will get the 10 recent contacts. Then we obviously need a function to insert a contact entity. Here we can say insert or replace. So if that already exists, that contact, we want to insert. So if there is a contact with that ID we want to insert, then we will replace it instead. So it's automatically also an update function. We want to insert something into the contact entity table. Here we specify the values we want to insert. So just all the values we have: last name, phone number, email, created at, image path. And then we specify the values we want to insert. And here we just have 6 or 7 question marks, since then the SQLDelete plugin will generate parameters for these, which we can then easily insert or pass to our function. And then 2 more functions. On the one hand, delete from, to delete a contact entity. So delete contact, delete from our contact entity table, where the ID is equal to the ID we pass. So we just delete a contact by its ID. And we want to have a function to get a contact by its ID. So select everything from contact entity where ID is :ID. And those are all of our queries now, which we can use in Kotlin code after we rebuilt our project. Maybe we don't even need this. Let's quickly take a look in, not main activity, maybe in contact photo, just to see if we have access to contact database. Yes, it is already generated, as you can see, so we don't even need to rebuild. Pretty cool. So next is we want to go to our common main, domain package, and here we create our contact data source. That will be an abstraction, so an interface we will use, which just defines the functionality we want to have in our review model or in our presentation layer to access some contacts, or to insert a contact, or to delete a contact. So on the one hand, we want to be able to get contacts, which will just return the flow of list of contact. So flow, just because that will emit a new value and the updated list whenever something in our database changes. Pretty cool. Same as we have that with room. We don't want to have a function to get the recent contacts, passing in an amount. This also gives us a flow of list of contact. We then want to have a suspend function of insert contact, where we pass in a contact we want to insert. That is a suspend function because we don't return a flow here. Oops, because that is a common question I get. Hey, Philip, why aren't these suspend functions, but these are? Well, because if we return a flow, then the flow itself already contains the suspending behavior, and the flow is rather just the wrapper. Whereas for inserting a contact, that is rather an action we do, and that is something we don't execute in a flow, or where we don't get a real stream of updates. So that is why that needs to be a suspend function, and that simply does not need to be one. And we will have a suspend function to delete a contact by its ID. I want to pass along here for the ID. And now that we have this abstraction, we of course need the implementation in our data package, because that is how things work in domain-driven design, that we really have that isolated piece of code in our domain layer right here. So this class does not use any third-party libraries or any library at all. It's really isolated. And if we at some point decide to change our database implementation, for example, from SQLDelete to Realm, which would also work for KMM projects, then we don't need to change any of the classes in our domain layer and only those in the data layer. That is the goal of such domain-driven design. Since in the end, all of our other classes will depend on this interface and not on the concrete implementation which we're about to create. And since this interface won't change, all the classes that use this interface also won't change if the actual implementation changes. I hope that makes sense. Just to also explain that for those of you who might not know why we have this domain layer and why we create such an abstraction for it. When I learned coding initially, I also never really knew why we use interfaces, but interfaces are pretty useful. So in our context package, we want to create our data package now. And here in data, we can now put the SQL contact data source. So that will be the real implementation which uses SQL. And what will this need in the constructor? On the one hand, our DB, which is a contact database that was now generated from SQL. And it needs a private variable, which we don't have yet. Let's leave that. This will later be for storing images, but let's do it one step at a time. We want to make this implement our contact data source. And in here we can hit Control or Command I to implement all these necessary functions. So how do we get this stream of contacts now from our DB? First of all, we want to get a reference to so-called queries just by saying db.contactQueries. That was generated from SQL. And with these queries, we now have functionality to actually access all these queries that have been generated here. And in particular, what we will do here is we will return queries that get contacts. So for every single query we define in our SQL file, we now have a Kotlin function. And this getContacts returns a query of type contact entity. That is the class that represents our database entity. We want to call as flow to get these queries as a flow. Then we call that map to list. So we actually don't have a flow of query of contact entity, but rather a flow of list of contact entity, which is what we want, or at least almost what we want. We have contacts here, we have contact entities here, so it's not fully done yet because we need to map these. We need to take these entities, which are the models we store in our database, and we need to map these to our domain model. Same reason as before, why we have these multiple models. This is our domain model, which is isolated, and we don't want to trigger a change in this domain model when we change our database scheme, for example. That is why we have separate models. On the one hand, those for the data layer, and on the other hand, that for the domain layer, which we use in our whole code base. And in clean architecture, we typically just define so-called mappers for that. So that will just be a normal function in Kotlin in our contact data package called contact mapper select file. And we now want to have an extension function that maps a contact entity to a normal contact. Like this. And here we can then just construct our contact object, pass in the ID. Is it a long or an integer? I'm not sure. Seems like it's fine. First name is first name, last name is last name, email is email, phone number is phone number, and the photo bytes, let's keep these null for now and add a to-do here that we want to get the actual image, because from our contact entity we get the image path, which is a string, and in our domain model we already read that in as a byte array. But since we don't have the functionality yet to read a file and to save a file in the first place, we want to keep this simple and leave it for now. Back in this SQL contact data source, inside this map block, we now want to map every single emission of this flow to it. So that refers to the list of contact entities, which you get from our database. And since it's a list and we want to map every single item of that list, we need to call that map again. So this outer map refers to mapping the emissions of the flow. One emission would be a whole list of contact entities. But since we also want to map every single one of this list, every single entry, so every single contact in this case, we need another map here. So here we could also give this a name of contact entities, and then just make this a bit more clear what this is. And here we then have an individual contact entity like this. And then we can say we map this to contact entity dot to contact. And boom, we don't have any errors anymore. We can then take this piece of code, copy it, paste it here for get recent contacts, because that's very similar. Instead of getting the context, we want to get the recent context, passing in our amount, and this amount seems to be a long. Let's just convert that to a long here, and the rest is fine. And then here we have the function to insert a contact, also very simple. We just call queries, insert contact entity. The ID is the ID of the contact we create. We pass the first name with contact first name. We pass the last name with contact last name, phone number with contact.phone number, email, contact.email, created at How do we create that? Because that should just be the Unix timestamp of, basically right now. And usually in Android, we use system.currentTime_millis, but in KMM, we don't have that because this comes from Java. And in KMM, we only have access to Kotlin-specific functions and libraries. And that is why we actually included the Kotlin datetime library. So we can say clock.system.now.2 epoch milliseconds. And that is how we get the current Unix milliseconds in Kotlin. And the image path is null for now, where we also need to add something later. So we need to also save the image before inserting a contact, retrieve the file path, and pass it here to save that in our database. And to delete a contact, we want to call queries delete contact by ID. Also not finished yet. Later on, when we delete a contact, we also want to delete the attached photo, which we again don't have yet. So now we are able to interact with our local database. What's the next step? The next step, I would say, is creating our view model, so we can really read in these contacts and save them in our state so we really see them on the UI. To do that, let's scroll to our ContactListViewModel, which we already have. And here we now need to provide this data source, the contact data source, and the constructor. And since that now depends on our abstraction and not on the SQL contact data source, this view model will never change if the implementation of our database changes. Also, if the schema of the database changes, this view model won't change unless we really add or remove a function of this data source itself. And to now read in these contacts in our state, where we have this contacts list and also the recent added contacts, we can't just assign the values here and read them once because we get flows back from this contact data source. That is why we need to make use of a combine block. So we need to say, actually state dot, not like that. We use combine. I'll explain that in a moment. We want to combine the state with contact data source that get contacts and contact data source that get recent contacts. Let's say we want to get the trendy most recent contacts. And in here, we now get a reference to the state, the contacts, and the recent contacts. So what this combine block will now do is it will take multiple flows. The state here is a flow, as you can see. This function returns a flow, and this function also returns a flow. And this block will now be called whenever any of these flows emits a new value, and it will provide us with all the most up-to-date values here. So we can now say what we return in this combiner is state.copy, and we just save the contacts from our database in our contacts table. We save the recently added contacts also from our database. And then after that, we call that state in. We want to state that in view model scope. We'll also explain that in a moment. Sharing started while subscribed, passing 5 seconds here. And we pass the initial contact list state here. We can then scroll up and remove this dummy list of contacts like this. Scroll down and remove this one here as well. Optimize the imports, and let's now take a look at what we did here. So whenever any of these flows emits a new value, we just make sure that we update our state automatically with the most recent result from our database. So if the context changes, so if we insert a new contact, then actually both these flows will trigger and will automatically update our state. Then state in, however, will convert that result. So combine itself just returns a normal flow. We want that to be a state flow. So state in will convert that to a state flow again. And this combiner will execute as long as there is a subscriber to that state flow. So as long as we listen to that with our compose state, and if the subscriber disappears, then this will be executed for 5 more seconds. That is how this works. And now what we can do is we can implement this onEvent function. So whenever the user does something on the screen which would trigger a state change, we want to react to that in this onEvent function. So depending on what that event is, we have a when expression. We can hit Alt-Enter to add the remaining branches, to just save us some time. When the user is about to delete a contact, so when they hit the trash can icon on a contact, we want to launch a coroutine in view model scope, since we need to execute a suspending function here, which is deleting the contact. And we first of all want to get a reference to the contact we are about to delete. We can get that with underscore state value dot selected contact, is that the contact the user will delete, dot let. This is the contact here. We then want to update our state with the same state, but we copy it and change a single field. That will be is selected contact sheet open. So we just hide the sheet. We then say ContactDataSource.delete contact. We delete the contact with the ID of the selected contact. And this could still be null. So let's add that here. Just make sure we're dealing with the ID. This will be the ID. And then we remove this. Then we delay this for 300 milliseconds. I will explain why. And we update our state by setting the selected contact to null. This 300 milliseconds delay is because of our animation delay. So later on, we will have a sheet here, which will open up when we click. Let's quickly switch to the other app. So if we add a contact, or rather click on a contact, you can see there is an animation that displays and shows this bottom sheet. If we now delete the contact, then there is a 300 millisecond delay until the sheet is hidden. Until then, we want to keep a reference to the selected contact, because otherwise all these values here of this contact will be set to null if we set the selected contact to null before, which is why we just hide the sheet before, wait for 300 milliseconds, and then finally reset the selected contact, since otherwise, we would just have null here for the name, null for the phone number, and you would see that for a fraction of a second on the screen. Yes, there would be better ways to handle this. I would usually not have a delay here, but since this will already be quite a long video, I want to keep this simple here. You could also implement a callback for the bottom sheet when it's fully hidden and then react based on that, but I'll just keep it simple here. Next up, we have this missing a contact. What should happen in this case? Again, ViewModel scope.launch. We want to update our state with it.copy is selected contact sheet open is false, is add contact sheet open is false. So we just hide both of our sheets, and we want to reset all the errors. Since if the add contact sheet is open and we dismiss it, so we click on the X icon, then all the errors should be reset. Since the next time we get back to the sheet, we want to start with a fresh state. Last name error null, then we have email error null and phone number error null. And then we want to also delay this for 300 milliseconds for the same reason, animation delay. Then we set the new contact to null. So the contact we're about to add should also be reset when we dismiss it. And also the same for the selected contact. That should also be null. Next up, we have editing a contact. So when we click on a contact, this will be called. Here we just update our state. So state.update, it.copy. The selected contact will be the contact we attach to our event, so that our sheet will automatically open up. We also want to set this is selected contact sheet to true. Oh no, actually when we added a contact, then we want to show the add contact sheet. So is add contact sheet open is true, but the select one should be false. Here. Since only in the add contact sheet we have these text fields where we can change the values. And therefore the selected contact should also be null, since if we get to the editing mode, we don't have a selected contact which we are currently inspecting the details of. And instead what we will do is we will have a new contact and we set that to event.contact. Then when we click on our floating action button and want to add a new contact, we actually want to update our state with it copy is add contact sheet open true. So we just show our sheet. And we then set our new contact, just to new contact with empty fields. ID is null. We then have our first name, which is just an empty field. Last name is an empty field. The email is an empty field. The phone number, empty. And photo bytes is a null initially, so we don't have a photo. And maybe just quickly explain why we have the separate compose state here, because I don't think this is obvious. Because we have this flow combiner here, which might potentially take a little moment to execute and save the final result in the state flow again. And we also save all the text field values of our contact, of our new contact, in a separate contact entry and not in separate fields that are put in our contact list state. We have quite some copy actions that are done before we type a character in our text field, before that is now saved and displayed on the actual, in the state and displayed on the UI. And because there might be a little delay between typing a character, processing that, and typing the next character, this can lead to race conditions that, for example, the second character that you enter will be displayed before the first one if the second one is processed quicker. And that is why we put that in a separate mutable state of, since there is no delay when it comes to updating such a compose state, or it's at least thread safe. So there's obviously a delay when we copy that, but it will in the end be updated atomically. So let's take a look at what the next event is we need to implement here on addPhotoClicked. We don't need that in the view model. We handle that outside of the view model. On email changed, now we have all the text field changed events, which is simple. We just, actually no, here we want to just update our new contact with new contact.copy, and we assign the email with the event.value. We then copy this and do the same for our first name changed, last name changed, phone number changed. So email, then here we have our first name. This one here is our last name field and phone number. On photo picked, here we can also paste this piece of code. This time we want to update our photo bytes after we pick the photo with the bytes that we attach to the event. Then saving a contact, that is the most complex event here. Let's start with select contact, where we just want to update the state. State.update, it.copy. Here I want to update our selected contact with the contact we attached. And want to show our selected contact sheet. So we set that to true. For saving a contact, what do we do here? What do we have to do here? We first of all want to check if our new contact exists, because only then we can save a contact if it exists. And now we need to validate all the fields of that contact, because we don't want to save a contact with an empty first name, empty last name. We want to validate the email, that it's a valid email, and that is business logic. So that belongs in domain, where all of our business logic needs to go into. So in our domain package, I will create a contact validator that will be an object, and it will just consist of a function called validateContact. We pass the contact to be validated, and it will return a validation result, which we create in this class here. That will just be a data class wrapper, validation result, and in here we will just put the results of that. So first name error, if there is a first name error, we put the string here. There is a last name error, we put it in there. Email error, and phone number error. If we would be super strict about clean architecture, then this shouldn't go in domain that we specify exact error messages, because error messages are just used to be shown on the screen, and whatever is shown on the screen usually belongs in presentation, but I want to not make this too complex. So if you wouldn't want to do it like this, and rather only keep such error messages in your presentation layer, then you could also return error code. So you could return an enum, for example, whether a field is empty, whether a field is just invalid and not in the right format, and then map that result, however, in your view model to such error messages. But let's keep it simple. Really not a fan to be too strict about such requirements of guidelines like clean architecture. Use whatever works for you in your project. Of course, if that would be a huge enterprise product, it makes sense to have such rules and structure, but we're just writing a context list app. So what we'll do here is we will specify our result as an empty validation result. We can also assign default values here, so we can instantiate it like this. So by default, we assume there are no errors. And now we check. If our contact first name is blank, so if the user did not enter something for that, we say our result is result copy, first name error. Let's put that on a separate line. First name error is the first name can't be empty. Let's actually still put it on one line. We then do the same for the last name. So I really want to keep the validation here simple. I just check for empty fields, and for the email, we will use a regular expression to check for a valid format. Last name error. Then for the email, we have an email regex, which is a new regex. And here we want to put the pattern, which I will just copy over from my prepared product. You can either copy this from my GitHub repository or just write this off, but make sure you don't make any mistakes. This is probably not a perfect regex for determining emails, but it will catch the most common formats of emails. So you can see there could be any number of characters before the @ symbol, then there has to be an @ symbol, then there is a domain, so Gmail, for example, followed by a dot, and then we have the actual top-level domain, so .com, .de, for example. Then we can check if the email regex does not match the email we entered for the contact. Then we want to say result is result copy, email error is this is not a valid email. And last but not least, phone number. For the phone number, I just check if it's blank, and otherwise we assume it's fine. Usually you could also use a regex for the phone number, but this I also didn't really find a well-working regex here that accepts any number and format of phone number. It never accepted my own one when I tried these, so let's also just keep it simple. If you're serious with that app, I'm pretty sure you will also find a regex. So here, a phone number error would be the phone number can be empty. And now we have all the errors saved in that result, so we can safely return it. Going back to our ContactListViewModel, we now want to use that function. So val result is equal to contact validator, validate contact, pass in the contact we want to validate, and then we can check our errors is a list of not nulls. So we can pass our result first name error, result last name error, result email error, and result phone number error. And this will automatically filter out all errors that are null. So if there are no errors, this would be an empty list, which you can then check. If errors is empty, that means everything is successful and we can save the contact. Then we want to say state update, it copy, is AddContactSheet open is false, so we hide it again, and we just reset all the errors to null. Last name error is null, the email error is null, and the phone number error is also null, so that next time we open this contact sheet again, there are no errors displayed. Then after that, after we updated the state, we say ContactDataSource, insert contact, pass in the contact we want to insert. We need to do that in a ViewModel scope, so ViewModel scope.launch, put that in here. Again, have our delay, 300 milliseconds, animation delay. We would, of course, also save this in a constant, which might make sense here. And then we finally reset our new contact. So same reason when we hide our contact sheet, our add contact sheet, and then we still want to keep the values of new contact so that they are still showing while the sheet is going to be hidden. However, if that's not the case, if we do have errors in that list, we just want to update our state with these errors. So first name error, result first name error, last name error, result last name error, email error, result email error. And finally, phone number error is result phone number error. And then we still get an error here, I think, because we did not implement all branches of that contact list event class. So we can just scroll down and ignore all other cases with such an else condition. So now we already finished our ViewModel. This is really all the code it will ever contain in this app. Sadly, we can't try this out yet since we don't have the UI yet for our bottom sheet. So that is what we will implement next, that our sheet will open up, that we can enter some data, and that we can finally hit save to save a contact and then hopefully see it in our list. Just one thing before we create our bottom sheet is that if we go to our app.kt here in our common main module, then you will notice that we now need to provide our contact data source here, so an instance of that. If we now were to create this here, SQL delete contact data source, then we need our database for that. And creating that database again, that just works differently on Android than it does on iOS. And to solve that, we will create a little factory class for that. So factory is just a design pattern that is used solely for creating specific types of objects. In this case, our data source or our SQL delete database instance rather. Now I'll put that in core, create a new package called data. And in there, we will create our database driver factory, because this factory class will create our SQL driver. That will be an expect class since it has different implementations on Android as it has on iOS, as I said. And all this really consists of is a function called create, which will return an SQL driver. Then let's go to Android main, core, create a new package called data, and put in our database driver factory in here. That will now be the actual implementation of that. And we have an actual function create, which will return an SQL driver. And here in Android, we just have that different way of implementing that, because here we need a so-called Android SQLite driver, which needs the context, which is something we don't have on the iOS side. So let's inject or pass the context here, pass the context here to our constructor, private val context, like this. And if we then take a look here in this constructor of this class, we first of all want to provide a so-called schema, which was generated by SQLDelete, that is called ContactDataSource.schema. We then need the context, which is just the one we passed here, and we need a name for our database, which I will just choose contact.db for. And that is how we create such an SQLite driver on the Android side. We now need to do the same on iOS. So let's scroll down to iOS main, core, create a new directory called data, and in here we will have our database driver factory. Make that an actual class as well. Actual function create will return an SQL driver, and creating that is pretty much the same as an Android, just that we don't need to provide a context. So we will just return a so-called native driver in this case, so native SQLite driver. And here we pass our schema again, ContactDataBase.schema, and the name is contact.db. And there we go. We know, or now each platform knows how to create such a driver, which is needed to create our database instance. And now if we go to our app file here, our very root composable of our app, then we still need to provide our SQL data source or contact data source. And normally in normal Android projects, to pass dependencies to a view model, we use something like Dagger Hill for dependency injection, or we create a view model factory, which we do here. But how do we handle these things in Compose Multiplatform project? Because Dagger Hill is a Java library which we can use in the shared section of our KMM codebase. And in the end, we can solve this problem very easily, because the core of dependency injection, what it's all about, is just passing classes to classes. So we have a class view model, and we want to pass another class, another dependency to that class in its constructor here. So we can just do very normal constructor injection, but I still want to have that central place for our dependencies, which we call modules in Dagger Hill, which I will also call modules here, where we just define how these different dependencies are created. And for that, we will go to our root package of common main. We create a new DI package for dependency injection. And in here, we will create a class called app module that will also be an expect class. And in here, we define all the different dependencies we have. And our very simple app here, that is just our contact data source, which is a contact data source. But since we again made this an expect class, we can have a different implementation of this contact data source on iOS than we have on Android. Let's take a look at how that will work. We scroll up to Android main, create our DI package, and in here we will create our app module class, which is now the actual implementation. And in here, we will then have our contact data source, which is a contact data source. This would now be an actual val, so the actual real implementation or real version of this contact data source. And we can just initialize this with by lazy, so that it just gets initialized the first time we access it, and then it will always refer to the already initialized instance. Something we need in the Android-specific module is just access to the context, since we very often need that to construct dependencies, such as our database driver. So in here, in this lazy block, we will now return an SQLDelete contact data source, which will then require a DB instance, which we can then create with the just created database driver factory. So we have our database driver factory. Since we are in the Android-specific module here, we need to provide the context and then just call that create. Doesn't work because we just created the driver, but not the database itself. Let's cut this out and create our contact database. This one here, and here we just need to pass the driver, and then it will work just fine. We can then take this app module here, copy it, and paste it in our iOS main, create a DI package here as well, and simply Control V to paste this, continue. We can remove the context since we don't have that on iOS. And in here, just creating that database driver factory works differently because here we also don't need to provide a context since we can just create a driver right away like this. We can optimize the import. And there we go. Now we have the option to create such an app module for both platforms to have a different set of dependencies on iOS as we have on Android. And then we can go to app and then simply pass an instance of such an app module here to this app composable. And here in our ContactListViewModel, we can then say app module.ContactDataSource. That is how we pass the reference from that app module to our view model. Then we just changed the parameters here of this app composable since we added this app module. Let's hit Control or Command and click on that. And then in both the classes where we use that, we need to adjust this. Let's start with the main view controller. Here we get an error because we need to provide an app module. On iOS, that's very simple. We can just create a new instance of that, which you can then always pass down to different composables wherever we need these specific dependencies, which we keep all in this app module here. If we then go back to app, command, click on that again, go to main activities or Android specific code, we also get an error here. So here we provide our app module as well, just that we here need to provide a context, which we can get with a local context.current. And let's also make sure we refer to the application context, so there are no some kind of lifecycle issues with the context if it refers to the activity. So that was just something we had to fix because we had an error, but now we can finally get to implementing our bottom sheet. And here a little disclaimer. There is no supported way for Compose Multiplatform at the moment to have a real bottom sheet in our app. We have a bottom sheet in Jetpack Compose, but that is for Android apps specifically. So inside of an Android app, we can use bottom sheets, but not on the iOS app. Still, we would like to kind of share that bottom sheet logic because the logic is pretty consistent. We just have a sheet that animates up and then we can close it when we click on the X icon. So I decided to create our very own version of a bottom sheet here. But as a little disclaimer, this will be a trash bottom sheet. So please don't expect that this bottom sheet works exactly the same as the real bottom sheet from Android, that it deals with all the different edge cases there might be. So in the end, we really just implement another composable which animates up and which we can close by letting it animate down again. And to get started with that, we're going to put that in our common main folder in actually core presentation. So that is something that might be shared between different screens. In here, we could call it simple bottom sheet, or we call it something like bottom sheet from Wish because it's just a bad bottom sheet, and please don't use that for real production apps unless the behavior you have here is all you really need and you also tested that on different devices, which I didn't. So let's call it bottom sheet from Wish. I like that. Create a new composable here, and that will be called bottom sheet from Wish with just 2 E's. Cool. Which parameters does that function need? On the one hand, we just want to have a Boolean whether this bottom sheet is currently visible or not. So if we want to show it or not, we then want to have an optional modifier, which is the default modifier. And we want to be able to pass some composable content, which is a composable lambda function. So this will just be the wrapper around all bottom sheets in our app. So this will deal with animating it, making sure it can be also closed and animated down in that case, because we effectively need to implement 2 of such bottom sheets in our app. On the one hand, for adding a contact, and on the other hand, for just showing a contact. And both these sheets will work the same, which is why I create this wrapper class. But the content of the actual composables will, of course, differ, because on the one hand, we just show a contact's photo, we show the actual text like phone number, email, but as real text and not as text fields to have these editable. That is only for the add contact sheet. And in Compose, we can very easily create such animations for composables that either show up or hide by using animated visibility. That is something we also have in Compose Multiplatform. And here we can pass whether this specific sheet is now visible or not. We use our past visible Boolean for that. And what we need to define is the enter and exit transition. So that defines how the animation will look like to show or to hide this sheet. So for the enter transition, when it shows up, we want to define that it actually slides in from the bottom. So we say that is a tween, which is just an animation spec. And Actually, not here. We first need to define that we want to slide in vertically. The animation spec is now our tween with the duration milli set to 300. So there is a 300 milliseconds duration of that animation. And the initial offset y, so where our bottom sheet will start to animate, is just it. So you can see it refers to the full height here. And with that, we can basically just define which kind of offset this slide animation should start. If we just leave it at it, that means it will start from the very bottom and then slide in vertically as the name says here. The same is something we should do for the exit transition. Let's copy that, paste it here and call it exit. This time it's not slide in vertically, but rather slide out vertically, because we want to hide it now for the exit transition. And here it's not the initial offset y, but the target offset y. And we also leave it at it here, so it just expands or moves completely down by its full height. That's it for the animated visibility. We can now open a composable block here to now define the content that should be animated. So whenever this visibility boolean now switches, then this animation will be performed. So if it switches from false to true, then this slide in vertically animation will be played. And if it switches from true to false, this animation will be played for the content we define here. And this will effectively just be a column where we want to pass our past modifier. We want to clip that so that we just clip the top left and top right corners of our bottom sheet and make these rounded. So here we have a rounded corner shape. Top start, let's say we have 30 dp, Alt enter to import dp, and top end 30 dp as well. And then after this clipping modifier, we want to set a background. The color will be material theme dot color scheme dot surface. That is what we use for bottom sheets. We then want to add some padding of 16 dp, and we want to add a vertical scroll modifier with, remember, scroll state, so that the content is just scrollable if it gets too large. Then inside of this column, we just put in our content composable. So in here, this would now be our actual screen content. So either our add contact options or the composables to display a specific contact. What you see here is we get a column scope. I would like to also provide this column scope to our content so that we can just also directly put in the composables that we want to show in this column and not need to create an additional wrapper. So we can change this by going up to our lambda function right in front of these parentheses, and we're going to have a column scope dot. So then we can only call this lambda function at a place where we have a reference to such a column scope, which we do have here since this comes directly from a column. But that will enable this content to also use column-specific modifiers, for example, such as weight or comparable modifiers. So now that we have that wrapper, we can create the specific version of our bottom sheet, which is our add contact sheet. For that, I want to go to presentation components of our contact feature and create our add contact sheet. Make that a composable. Which parameters does it need? On the one hand, it needs our state, our contact list state, since it obviously needs to access all the different values of our state. So if it's open, if the like the new contact, which we also need to pass here, since that is a separate state, which is a nullable contact. We want to have a boolean whether it's open or not. We want to have an on event, a lambda, which sends contact list events up to the parent composable, and we want to have an optional modifier. And in here, we're then going to make use of our simple, I call it bottom sheet from wish. Bottom sheet from wish. It's visible if is open is true. We then have our modifier, which we can pass here. So modifier dot filmmax width. And here we can now put in the content for our add contact sheet. And if we take a look here at how this sheet will look like, this is the content of it. We'll first of all have a box around everything, since we can then easily arrange this icon button here at the top start. Inside of that box, we will then have our column. So in that column, we will just stack all these composables here. So our clickable photo, we have 4 text fields, and then finally our save button. Let's start with our box, which we will pass a modifier to with modifier.filmmax size, and the content alignment will be set to top start. Inside of this box, before we get to our icon button that will be at the very bottom of the box, since then it will show up on top of everything. Inside of this box, we will first of all put our photo. And I actually first want to have a little spacer. So modifier height of 60 dp, Alt Enter to import dp. This will just cause that we have a little bit of spacing and the content won't start at the very top here. And we actually want to put that in a separate column. Otherwise, this won't work the way I want it to work. So this column will also have a modifier of modifier FillMax width. We will have our horizontal alignment set to alignment dot center horizontally. So we center everything here. For example, this photo and the button below. And we then put in our spacer in this column. We could then actually already implement our icon button below. So we have an icon button for dismissing this. When we click this, we want to call on event with ContactListEvent.dismissContact. And here in this icon button, we have our actual icon, which is this one here with the image vector. The image vector will be icons.rounded.close. And the content description will just be, I don't know, close or so. That will already be arranged in the top start here. So we can now start to implement our photo here in our column. So if there is a photo for the contact, so a real photo, then we just want to show the photo. So just an image composable. If there is no photo, we want to display this selectable photo thing kind of where we can just click on and then add a photo. So if new contact.photoBytes is null, that means we want to show the option to add a photo, which will just be a box with an icon. The box will have a modifier of modifier.size 150 dp. We then want to clip this to a rounded corner shape, 40% rounding. We then want to have a background of material theme, that color scheme, that secondary container. So it actually has this bluish color here in our theme, or it at least adapts to the dynamic color theme. We then want to make this clickable. If we click on it, we have our onEvent callback for ContactListEvent dot, what is it? On add photo clicked. And last but not least, I want to have a little border here. And the border will have a width of 1 dp. It will have a color of material theme, color scheme on secondary container. And the shape will also be a rounded corner shape with 40% rounding. We then also want to pass a content alignment of center here. So we want to center the plus icon inside of that box here. So here, icon, image vector is icons rounded dot add. Content description is add photo. We want to change the tint of this to material theme, color scheme, that on secondary container. And we want to change the modifier to increase its size to modifier size 40 dp, like this. And that is already what we need to show our little photo if there is no photo at the start, or when the contact does not have a saved photo. If it does have a saved photo, we need to go down here and have an else block. Then we just display our contact photo composable, which we already have. The contact is our new contact. The modifier is modifier size 150 dp. And it has a clickable lambda where we will call on event ContactListEvent on add photo clicked. So if there is already a photo and we click on that, then we obviously also want the user to be able to edit it. And all that's now really remaining here on the screen, on this bottom sheet, is every text field and the save button, which is pretty simple. For the text fields, I want to have a composable down here, which is called contact text field. It'll have a value, so the actual text. It'll have a placeholder, which is a string. It'll have an error, which is a nullable string, an on value change lambda, which gives us the new string, so the new value, so we can update the state, and it will get a modifier. So this contact text field will now just be for showing this text, styling it a little bit, and also when there is an error, for example, like when we hit save here, that there is the option to show an error message below this text field, which is this nullable error string. So we just have a column here, pass our modifier to it, and then we use an outlined text field. So the material one, the value is value. Then we have a placeholder where we can assign, a placeholder is equal to a lambda. We can have a text composable, and the text is our placeholder text. We then, this doesn't work. It should work after we created all the parameters. So let's go ahead with onValueChanged. That is equal to onValueChanged. What is it called? onValueChange? onValueChange it is. We then want to pass a shape to this, which is a rounded corner shape of 20 dp rounded corners. And I want to pass a modifier to it of modifier.fillMaxWidth. And for some reason, it still gives us errors. Okay, it's just because the experimental import. Let's add this, and then there are no more errors. What do we do with this error message? Well, if there is one, we want to show this below. So if error is not null, then we just want to show an error text below. The text is error, and the color is material theme.colorscheme.error. We can then scroll up and use this contact text field here below this if-else condition, right here. First of all, a little bit of spacing, modifier height 16 dp. And now we have our contact text field. The first one will be for the first name. So the value will be new contact dot first name. There is no first name, it's just an empty text field. Placeholder will be first name. The error message will be state.firstNameError. OnValueChanged will be onEvent ContactListEvent.firstName changed with the new first name. You can also put this on a separate line. I think that's better. And finally, our modifier is modifier fillMaxWidth. And that is just how easily we can now create a text field for our contact. We can now just take this, copy it, paste it 3 more times, 1, 2, 3. For this text field, this will be the last name. So new contact dot last name, state last name error, and on last name changed. This one here will be the email address. So email error, and on email changed. And here, that will be the phone number. Phone number error, and on phone number changed. Like this. Let's then have one more of these spacers below, and we will add our button to save the contact. On click will be on event, ContactListEvent.SaveContact, and this button will just have a text of save contact, or we just call it save, for example. And that is our add contact sheet. This should be complete, which we can now use on our contact list screen. So let's open that. And we can just put this composable at the very bottom below our scaffold, since it should also show up above our scaffold. So right here, add contact sheet, state is just our state. New contact is new contact, is open, is state.is add contact sheet open. On event is on event, and the modifier is actually something we don't need to pass here. And I'm not sure if this will already work, but since we already have our view model logic, since we have our real database implementation, and we have the option to enter something in our UI, I will say we try this out and see if this works on Android at least, that we can actually insert a contact and see that in our contact list. Here's still my old app. Let's take a look. We now want to click on add. Hopefully this will show. Yes, it shows the sheet. It looks exactly as I want. If we close it, it will hide again and so on. So this is our bottom sheet from Wish. Obviously, nothing happens if we click this because we haven't implemented the functionality to show our image chooser yet, which we will do right afterwards. But let's see what happens if we just click save without entering anything. Then yes, we get all the valid errors. Phone number can be empty, not a valid email, first name. Oh, here I'm missing the last name. Let's go to our AddContactSheet. Either I didn't change this here. No, I did change it to the last name error. Then the error is in our validation. So in our contact validator here. Contact last name is blank. Then let's just change this to the last name. Can be empty, relaunch this. And then this should be fixed. There we go. Let's open this. Save again. Now it's last name. But if we enter something here, Philip Lechner, of course, you could also implement that the errors automatically hide as soon as you enter something. You could have an email, for example, test. Let's just enter an invalid email for now to check if the regex validation works. The phone number is something like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9 or so. And if we now hit save, then only the email error remains. If we now enter a valid email, test@test.com, hit save, then there is our contact. So everything seems to work just fine for now. We see our contact, and obviously if we relaunch the app, then since it's saved in a database, we should still see our contact. There it is. We can't click on it yet so that we see its details, but that is what we will do after implementing the image picking stuff. So I would say let's move on with that. And you probably already guessed it, that image picking is something that just works different on Android than it does on iOS. So that again is an indicator that we need to make use of expect and actual functions and classes here. So first of all, in core presentation, I want to create a class called image picker, which will be this expect class, so the abstraction behind it. And here we will first of all just have a composable function, so a function called register picker, because on the one hand we need to register that we have such an image picker, and this will give us a callback on image picked, which will give us the byte array of the image that was picked. This is a composable function since we need to register this picker in a compose context, but we also want to have a function pickImage, because after we register the picker, we can then use pickImage to kind of execute it and to really see our gallery with all our images to launch the picker in the end. Now let's start with the Android-specific implementation by going up to our Android main, presentation, a core presentation, and creating a new Kotlin class called image picker. And for this Android side, you maybe already know how this works with picking an image. Here we need a reference to our activity in form of a component activity. And we will work with so-called activity result contracts. So what we'll do is we will launch an activity for a result, so the gallery activity in this case, and the result is just the picked image. And we can do this with such a contract or launcher. Private latent var, it's called getContent here in Android. And that is an activity result launcher. And here, as a generic parameter, we need to pass the type of argument we pass to this launcher. In this case of getting content, it's just a string where we pass the MIME type of what we're looking for. So in this case, we only want to get images, so we'll pass the image MIME type to that. We then have a composable function called register picker, which will give us an on-image picked callback with our desired byte array. Like this. This is now our actual function, and we also want to have an actual function pickImage, which doesn't need any parameters, and will just execute our image picker. Here in register picker, we will just initialize our getContent, which is activity.register for activity result. The contract is contract. I don't think we can use name parameters here. The contract is just activity result contracts.getContent. And then in here, this is the callback that will fire with the image URI that was picked. So we get our URI reference here. And if an image was picked, so if the URI is not null, if the user just went back, then this will be null. If there is an image, so if there is a URI, we need to read it in with our content resolver. So activity, content resolver, open input stream by passing our URI. and then calling that use to open this input stream and also close it after this use block. Then we want to call image picked, and the byte array is just our input stream that will read bytes. And in our pick image function, we will just use our get content, and we call launch to open the picker. The MIME type is now what we need to pass for this input. This will be image /*, so any type of image. And this is how we pick images on the Android side. We now need to do the same, just with the iOS-specific implementation. For that, I want to go down to iOS main, core presentation called image picker, actual class image picker. And here in iOS, we also need a constructor argument, which is different from Android. This time it's called root controller, which is a view controller. How's it called? UI view controller. So this is basically, it's comparable to the activity in Android. So just the root UI view, which is needed as reference here in this image picker to be able to show this opening pick image sheet on iOS. So in here, we want to have a private val called image picker controller. That is how the thing is called in iOS, which we use to pick images. This is a new UI image picker controller. And we call that apply on that because we want to set the source type. So what kind of things we are looking for, what kind of images. And that is UI image picker controller source type photo library. This one here. It's a very long name, but it basically means we are looking for images in the photo library. So let's make sure we set the correct source type like this. Then we want to have a private var for onImagePicked, which is our lambda, which gives us our byte array. You will see in a moment why I make that a separate member variable here. We just set that to an empty lambda for now. And then we have something called a delegate. In iOS, that's basically comparable to an interface, or not really an interface, but just something we delegate the work to. So in this case, we want to react to something, or we want to react to a result of this image picker controller. So what we'll do is we will have an anonymous class here, which will inherit from NSObject, which is just an iOS-specific object. But most importantly, we want to implement two interfaces here. In iOS, those are called protocols. On the one hand, UI image picker controller delegate protocol. These have very long names. And on the other hand, UI navigation controller delegate protocol. Those are really just two interfaces we want to have here, so we can override the functions we need to react to these image pick events. We can hit Control or Command O to check all these functions we can override now. Scroll down to our image picker controller delegate protocol, and this is the image picker function we want to override. Actually, this one here, and also this one. So the top one, image picker controller, which is a weird function for a weird name for a function, gives us this UI image, so the picked image, which you can then do something with and read as bytes. And this one here is used to react to these cancel events, so when the user canceled picking an image. We want to override both of these, and in the iOS main folder we can't use super, so this will lead to an error if we call it like that. So let's remove these super calls. And how do we now get the byte array of this picked UI image? So what we could do is we could create a byte array here, a Kotlin byte array, and this will take a size, which we don't really get from this did finish picking image. There is no real size or so. There is actually, but it's not really like a Kotlin integer or so. So something we need to do before is we need the image as NS data. So which is something like a data specific type of Swift or of iOS, and we get that with UI image JPEG representation. Here we can pass our did finish picking image, which is our UI image, and the compression quality is just a float. And then we can use this NS data here, image NS data dot length, actually that length dot to integer. Since this could be null, let's add a return statement here. If this is null, then just return out of this function. And then we now have our Kotlin byte array with the real image data. This byte array does not yet contain the bytes of the image because we just created the byte array and defined how long it is, so how many bytes will fit into this array. But we still need to copy the bytes from this real image into this byte array. And here in the iOS main module, we need to do this with memcopy. So memcpy, which is very unreadable because this is initially coming from C code, which is pretty much unreadable by convention. So in here, we basically just want to call our bytes, refer to the very start of the byte array, then specify the actual bytes from where we want to copy. So this is the destination here. So where we want to copy something to, which is just the start of our byte array. Then from where do we want to copy? From image NSData.bytes. And the size is again just image NSData.length. Then we don't have any issues anymore, and we can finally call onImagePicked, because now we know that we copied these bytes to our byte array, and we can call our callback with bytes. And then we can also say we use our picker, and we call dismiss view controller animated. So we just dismiss our controller, want to pass through here. And for the onCompletion lambda, we actually don't need that. We can call a null. We can also copy this line and also do the same for when we canceled picking an image. So then we also just want to dismiss it without copying something before. But now we just defined the delegate. We did not yet assign the delegate. So what we want to do is we now want to implement our actual function, register picker, which will give us this onImagePicked callback with the byte array and returns a unit. This is a composable function. And in here on the iOS side, that is very simple. We just want to now assign this pass lambda to our global lambda. And because we need this lambda here in our delegate, which is a separate field, we now just needed to make this a public, not a public, but a member variable of this. So we can refer to this lambda in both this delegate and in this register picker function. And then here in our actual function pick image, we now want to launch our image picker controller. And to do that, we use root controller that present view controller to just show the image picker. For the view controller to present, that is just our image picker controller, which we've created. And animated will be true. So yes, we want to animate that. And we get a callback, which is called as soon as this is showed up, because here in this callback, we want to call our image picker controller and finally assign our delegate that we created above. We can't do that in the apply function here. I've tried that, but it won't work. You have to reassign the delegate right after the picker has been shown. So we got to do it here. Okay, the next thing we need to do is something similar to what we also did with our database or creating our database. We now need to create a factory class for our image picker, so to create such an image picker. The reason is the same as why we needed to do that for our database. So if you remember this database driver factory here, we just created that class since creating such an SQL driver in this case required parameters on the Android side, which it doesn't require on the iOS side. So on Android, we needed the context. On iOS, we did not need that. And it's now the same reason we need to create such an image picker factory, since on Android, we also need the context, or rather the activity reference, so we can show the image picker on that activity. And on iOS, if you remember this one here, we need this root controller, which we obviously don't have on Android. So in core presentation, I would also create a new image picker factory class, which will be an expect class, and it will have one composable function, which is called create picker, and that will return an image picker. We can then take this factory class, copy it, go to, let's start with Android again, go to Android main presentation, paste this here, image picker factory. This time it's of course an actual class, an actual function, since here we now need to return the real picker. So we want to return an image picker, and here we need the activity reference. How do we get that on Android? Well, since we are inside of a composable function here, we can just get it with val activity is equal to local context.current as component activity. Since the context we get here is always the activity context, we just need to cast that as a component activity, and then we can pass it here, and that will work just fine. One thing we just need to make sure here is that we wrap this inside of a remember block. So let's cut this out, remember, and whenever the activity changes, we want to create our image picker. Otherwise, we would create such an image picker here on every single recomposition. That would be a side effect and terrible in Jetpack Compose. So definitely make sure to use remember, so it will cache this created instance across recompositions. Then let's take this image picker factory and also paste it now in iOS main presentation. We're going to click continue. This time, this class will need the root controller. So the UI controller, as I mentioned, which is just similar to the activity just on iOS. That is needed to show this image picker dialog or image picker sheet. So private val root controller is a UI view controller on iOS. Then we want to remove this code here and also remove our unused imports. And in here we then just return an image picker, actually also inside of remember like this. And we create an image picker with our root controller. Import remember, Alt enter. Then to use this image picker and now to try it out, if we can at least pick images, we can't save them yet. That is what we haven't done yet, but we should be able to pick them and make them display in our image composable. So let's go to our app composable, so the very root composable, and we can't really provide this image picker or make it part of this app module here, since in this app module we don't have access to this UI controller on iOS on the one hand, but also to the activity. That is also the same if you use Dagger Hilt on Android. Then you can't really use the activity context to create something, because that could of course differ, and there is no fixed activity because your application could have multiple activities, and we need to create these dependencies once when our application launches. So there is no activity reference just for the application context. And that is why we just can't have this image picker as a dependency of our app module, which is why we go to app and simply add this here to our parameters. We then want to also add this to our contact list screen. So here we also have an image picker parameter. We can then command click into that to also add it here. Image picker is an image picker. And now in the screen here, we can now use this to actually launch this image pick request. On the one hand, we want to make sure that we first of all register the picker. So image picker dot register picker. And when that image was picked, this Lambda will fire with our image bytes. In that case, we'll call on event on photo picked. And we pass our image bytes that we got from the picked image. That just registered the picker. We of course still need to execute it. So after registering it, we need to say, hey, when we click this button or when we click on our image composable, we now really want to show that sheet. For that, we're going to go to our add contact sheet because that is the place where we want to show this image picker when we click here. So we want to kind of intercept this on event Lambda and get our event here. And then just call on event with our event, but we want to check if that event is on add photo clicked. So when we click on that, then we want to take our image picker and pick the image. And all other events will just be forwarded to the on event Lambda. Actually all events, not all others. So this event will also be forwarded here, but we just want to intercept this because we don't have access to this image picker in our view model for the reason I just mentioned. So what is now missing to be able to try this out? Well, we only need to make sure that wherever we call this application composable, we also pass this image picker. So we just haven't created it yet. On the one hand, want to go to main activity app. Here we get an error because now we need to create this instance, which is simply image picker factory with nothing, but then we call create picker. And since that is a composable function, we don't need to make sure that we wrap this in remember or so, because we already do this here in create picker. Then I'm going to the main view controller in iOS main. Here we also need to create that. And this time it's again image picker is image picker factory. This time we need to pass the root controller. How do we do that? How do we get the root controller in iOS? Since it's actually this kind of controller here, but inside of this composable context here, we don't have a real reference to this controller since we create that with that composable context. But luckily, JetBrains thought of that, and there is also composition local. So we can say local UI view controller.current to get the view controller. And then we call create picker. And that is it for our image picking functionality. I would say we try this out on Android for now. Take a look here and wait until Gradle build and launch this. There we go. Now let's click on add contact. And here we now want to click on this image composable And something happens. We do see our image or our file library actually. And I'm not sure if I have some photos here. Let's click on that. It seems like I don't, since that's empty. So what we will do is we will go back here. We will minimize this and we actually take a photo. Open the camera app and then we will see our emulator camera here. Yes, got it. Let's just take a photo like this. And we should now have a photo to pick. Go back to our app. Add this here. Seems like it doesn't appear. Is it in our images, pictures? Yes, there it is. Let's select that. And it does show up. So that is very cool. So picking images works, at least on Android. We could also try this out on iOS, by the way, since we haven't launched this in a while. Just one thing, if we would save this now, as I said, this image won't be saved. It won't show up for that contact since we don't have the mechanism yet to persistently save images on our file system. That is what we're going to do next. But I would say let's open this in Xcode by going to our iOS Contacts MP Xcode projects. And we want to open this in Xcode. Now it seems this is still open. Very cool. iPhone 14 Pro, that is my simulator. Let's launch this. I don't think we should make any changes here. Apparently the build failed. Let's take a look. Okay, I see why. You can notice that the error seems to be related to SQL, and there's just one thing we need to adjust in Xcode in order to be able to use in the SQLDelete library or an SQLite database. That is something we can't configure in our Kotlin code, but we need to go to our root project here in Xcode, click on our project to get to the settings. Want to get to build settings. We then want to filter this for the so-called other linker flags. This one here, this setting, we want to double click on that. And here we need to add one flag that is applied, which is -LSQLite3. That is making sure that we can also use the SQL library, the SQLDelete library on iOS. We can then close this again, run this again, and hopefully now the build will be successful. It had still failed. Didn't it apply that? Let's take a look in iOS Contacts MP, and for some reason it's not in here. LSQLite3. That is what it needs to be. Now it's in. Let's relaunch this. Take a close look that it doesn't remove this. Now it succeeded. Okay. I don't know what the reason was why it removed that, or if I'm just dumb but I missed something. But it now seems to launch. I will see you back when it fully launched. There we go. Here's our empty contact screen. Let's click Add. You can see it's a little bit laggy here in iOS. That is one downside of Compose Multiplatform at the moment, which I also noticed that if you have animations, then these can be quite laggy. But obviously, it's still an alpha. So let's ignore that for now, and I assume this will get better. What we're going to do is, let's first of all click Save to see if the error handling works here. Yes, it does. Let's click on Pick Image, and does something up. And yes, our image picker sheet opens up on iOS as well. If we pick an image, then we do see it. Yeah. So everything is working fine. The next step, as I said, will now be to take these images. When we hit save, we want to put these images as a real file in our local file system of that app. So we can also show these in the list of contacts. So let's go back to Android Studio. And by the way, you can also launch the app here from Android Studio right away. So iOS Contacts MP. I'm kind of used to launching it from Xcode, which is why I usually took that path. And now we also needed to adjust something there. But you can also launch it right from inside of Android Studio. Okay, how do we now store our images? And maybe you already guessed it, that is something that works different on Android than it does on iOS. So we again need to make use of Expect and Actual. It's still quite simple. It's not super simple, but it's okay. We can manage that. Let's go to Common Main. First of all, define our image storage class. So let's do that in core data. We have our image storage. That is a class, expect class. It will have three functions. On the one hand, a suspend function to save an image. That will just receive a Kotlin byte array, which represents the image. And it will then return a string. And that will be the final file name under which it saved that image. So we can then take this file name and save it in our local database. So we don't need to take this whole long byte array of an image and save it in our database, but rather just save the reference to it. Next up, we have a function to get an image. So if we load a contact, we obviously need to load the image as well. This will take the file name, which is the string, and it will then return a byte array, which is nullable in this case, since if the image doesn't exist, we still need to return something. And last but not least, we want to be able to delete an image if we delete a contact. And for that, we just need the file name. If it exists, we will delete it. Then let's start with Android again. Android main core data. In here, we will have our image storage class. This time an actual class, and it will need a reference to the context. Private val context, this one here. And the Android version will actually be quite simple. Maybe you've heard that dealing with storage on Android is quite difficult, but in this case, it's really not, because we're only dealing with internal storage. So on Android, we have internal storage and external storage. External one is the one that is potentially shared with other apps, so that other apps can also access these images. But in our case, we don't really want that. We want these images to be just to be safe for our app, so our internal storage. That doesn't require any permissions, and that doesn't require any fancy handling between different API levels of Android. It's pretty simple. So let's start with an actual function, actual suspend function. Save image takes the byte array, and returns the final file name under which it saved that image. And here we want to return with context dispatchers.io. So we just make sure we want this on the IO thread. And then we want to get the file name. So we just want to generate a random file name. So we make sure those are unique. We then say that is UUID, that random UUID, that toString, and we say plus that JPEG, like this. If you would be dealing with different types of images here, you could also parse the extension here. I just assume we're only dealing with the JPEGs here, but if you also have PNGs or so, you would need to consider that as well in this case. But let's keep it a little bit more simple, since this video is already super long. So now, how do we take this byte array and write it into a file in our internal storage on Android? It's very simple. We just use context.open file output. So we want to write something out in a file kind of, instead of reading something in. And here, the first parameter is the file name under which we want to save this. And the second parameter is the mode, which is private here, so context mode private, so that only our app can actually write into this file. We then say .use, we used that before, since we get a file output stream here. So we could say output stream like this, and then we say output stream.write, which takes a byte array, and we write our bytes into that stream, and finally into that file under that file name. And then we just use our file name to return that after we've written into that file. That is how we save an image. Next up, we want to have a function, an actual function, suspend function, not an actual CL class, actual suspend function to get an image with a specific file name. We'll return a byte array nullable. And here we just need to find the image under this file name, read it in, since that will be a file. We need it now as a byte array again. So we just reverse the same thing as we did for saving an image. So again, return with context dispatchers.io. So we say context.open file input this time, so not file output. Here we pass our file name. So from which file we want to read something, and then we say .use, and we just say our input stream .read bytes. That is how easily that works to get an image. And last but not least, we have an actual suspend function to delete an image under a certain file name. Also, return with context dispatchers.io. And in here, we're going to say context.delete file name. That's it. And now the rest is for iOS. So now we have our Android-specific image storage. Now we also need an iOS-specific one, which is actually more complex. So let's take a look at how that would work. In iOS main core data, we want to have an image storage class, actual class, with an actual suspend function called save image, takes our byte array, and returns a file name under which we save that image. And on iOS, we first of all need two global references. On the one hand, the so-called file manager, which is ns-FileManager.default manager. And we need a reference to the directory where we want to save this image. So this will be the document directory, and we can get this with ns search path for directories in domains, very long names here on iOS. On Android, we didn't need to do this because this open, where is it here? this open file output will take the root of our internal storage by default. We could also create folders here, but on iOS, we need to get an explicit reference to this document directory because storage just works differently than it does on Android. First of all, we need to specify the directory, which is ns document directory, this one here. Then we want to specify a so-called domain mask. So that will restrict the search for the document directory to the user's home directory, which is ns user domain mask. So if we choose that, then it will restrict it to that. And we have expand tilde. I don't know if that's how you pronounce it, but we set that to true, since on Linux file systems, you have this little tilde symbol. So this one here, which refers to the user's home directory, and you want to expand this here for this document directory reference. And then to get the actual reference of that, we refer to that first, since that returns a list of directories, and we cast that as an ns string. So that's kind of an iOS specific string reference, just to be sure that this is a different type of class than the Kotlin specific string, but we can still cast this here as we like. And then again, we need a file name, which we generate with UUID. Do we do it with this? No, we do it NSUUID. Dot UUID, dot UUID string, this will return a random UUID, and we say plus JPEG. And then we need the full path, which is not simply our file name as on Android, since we need to take our document directory path and append this file name. So I'm going to say document directory, append, or string by, this is called string by appending path component with our file name. So that will simply take the document directory path and append our file name with all the necessary path separators. And now it's not as easy as an Android to just take such a Kotlin byte array and write that into a file in iOS, because iOS itself doesn't know these Kotlin byte arrays. So we need to convert that to a data type that works for iOS. So we have our actual raw image data, which is bytes.usePint. UsePint is a function that is used in Kotlin native in some cases. So in pretty much Kotlin projects that aren't Android-specific projects, for operations that require direct access to memory without actually making the garbage collector move around data or move around bytes. So in the end, since we are directly dealing with, I think it's our Objective-C code here, we just get a stable pointer to data. So we just make sure this pointer remains stable. The data will remain there until we finally write it to the file. So in here, we say ns_data dot create. This function will on the one hand take the bytes, which is in form of a C opaque pointer, which we simply get with this pinned reference. So this pinned byte array dot get, actually not get, we want a pointer, so address of, and here we say 0. So we just refer to the very start of our byte array and point to that. And then we have our length, so the length of our byte array, which is bytes.size.to unsigned long. And then we have our reference of ns data, which iOS now understands. And then we just need to say data, write to file, the path is our full path, and atomically is true, so we don't run into any race conditions. And then we can finally return, what is it? Our full path, which we will then save in our database. We should also wrap this in with context, I'm just noticing. So return with context. And in iOS, we don't have the IO dispatcher, so we would need to use the default one. Let's take this whole thing, this thing, and move it in there. And then we remove the final return. Cool, that is our function to save an image. You can see it's a little bit more complex as it is on Android. I'm sure if you do this natively in iOS, it's a bit simpler, since you don't need to do this Kotlin byte array conversion to this ns data, but it's fine here. Let's go here and implement our next suspend function called getImage. I want to get an image with a file name, and that will return a Kotlin byte array. How do we do that? We again use ns_data dot what is it called? Data with contents of file, which will just take a file name, this one here. If that file exists, so we can make a let check here, then we get the bytes, which is in this case ns_data again, so not a Kotlin byte array. So we still need to convert that. How do we do that? We use this bytes reference we call getBytes, and here we need to again use this C opaque pointer. So this function will then take the contents of this ns_data and copy that into a Kotlin byte array, which we first need to create here. So that array is an empty byte array with the length bytes.length.toInteger. And then we say array.ref2, which will return this pointer. So we refer to the first or to the starting address of this byte array again, and then we call .getPointer. This will return, not return, this will require a so-called auto-free scope. This is again required because the memory management on Objective-C works differently than it does on Android with the garbage collector and things like that. How do we get this auto-free scope? So we just make sure that this memory is freed up after use again. For that, Compose Multiplatform has something called memScoped, which gives us this lambda block. And here we have this memScope, which is such a scope. So we can just pass this, so the scope, and then the length of that is just array.size. Or actually, we can also pass bytes.length. After that, if that was successful, we want to return our array. We also want to use with context again. So with context, dispatchers.default, put this in here, put this in here. We then need to change this return to return add with context. Add a return statement here in front of it with context. And if we did not return inside of this with context block, we then want to simply return add with context null, like this. Okay, as you noticed, that was also a little bit more complex than on Android, but the delete function is as easy as it is on Android. So let's just have our actual suspend function, delete image. The image will have a file name of string. And here we will just have with context, dispatchers default, and we say file manager. This is now where we need our file manager. Remove item at path with our file name, and for the error, we just insert null. Cool. That is how this works in iOS. As I said, a bit more complex, but should work exactly the same. So where do we now need to create this image storage reference, and where do we need to use it? We only need to use this if we scroll up to our SQL.ContactDataSource only in here, because whenever we save a contact, here, when we insert a contact, we first of all want to take the photo bytes of that contact, save that in our image storage, and then insert that in our database. And whenever we delete a contact, we just want to take this saved file path of that contact we're about to delete and also remove the image here. And when we get contacts, so in this function where we map these contacts, here you remember this to-do statement. Here we need to use our image storage again to retrieve the photo bytes from our file system. So in short, all we need to do here is we need to have a reference to our image storage in our ContactDataSource. Then in our toContact mapper, we need this reference as well. So we can just go in here and say image storage.getImage, and the file name will just be photo, how did I call it? Image path. But only if this image path is actually not null. So let's use let here, image path $let. Then, so if it's not null, then we want to use image storage get image with it, which is the file path. This now also needs to be a suspend function. So let's make it a suspend function here. However, while this will work in our ContactDataSource, if we pass our image storage here, as you can see, there are no errors. This is not optimal, because what will happen here is it will execute these mappers here sequentially. That means it will first load the image of the first contact, then it will load the image of the second contact, then the third one, and so on. However, loading these images doesn't really depend on loading the image for the last contact. So what we could do is we could execute all these calls in parallel, that we just load all these images at the same time, since they don't depend on each other. How do we achieve that? We can use something like a supervisor scope, which gives us access to a launch and async, which will launch independent coroutines which run in parallel. And then we can say contact entities.map, and we now map this to async blocks where we say it, so the contact entity dot to contact with our image storage. Since this is now the suspend function that is executed inside of this independent async block, all these async blocks will now be executed at roughly the same time. And to get the results of these async blocks after they have been finished executing, we can use another map block down here and say it.wait to get the contact result. And then we can remove this piece of code. This is just how we execute all these map functions here parallel, but that's obviously only needed if your function is a suspending one, which it is in this case, but usually mappers are not suspending. So let's now take this and also paste it here for the getRecentContacts function, and then we fix that already to load images from contact. However, we don't save these right now. So in here, before we insert a contact, we'll make sure to get the image path by saying contact.photoBytes.let. So if the photo bytes exist, then we call image storage save image with that byte array, which will then return the image path. And we can then take this image path and save it in our database. And for deleting a contact, we first of all want to check if there is a saved image with that contact. So we need to retrieve it from the database. So the entity would be queries.getContactById. We pass the ID here, and we actually also need to call execute as one. So we just tell SQL delete that we only expect one result out of that. And then we say entity.imagePath. If that exists, then we call our image storage delete image with that file name. And after that, we just delete the contact from our database. So now we adjusted that, and I think we should be able to try this out. We just need to pass this image storage reference to our SQL data source, which we can do here in our app module. I'm actually not inside this one. We need to go to app module in Android main. Here we get an error because we need to say image storage. Image storage? Not here, actually. Here, image storage is a new image storage where we pass our context. We then go to our iOS main, di app module, and here we say image storage is image storage. Here we don't need any constructor arguments. So I would say, let's launch this and take a look if we can actually save such an image and really see that in our list. And you didn't see that, but the app actually crashed. So let's take a look and look at what the issue might be. Not sure what to select here. Is there our app? Now it actually inserted the logs. Let's search for errors. Okay, so the issue is something Compose related. Main activity is attempting to register while current state is resumed. Lifecycle owners must call register before they started. Okay, the issue seems to be inside our image picker here, because this should be how we do this. And no, it's actually not how we do this. I'm just noticing I'm using the non-compose way to initialize that. So let's not do it like this and instead use the compose import. So remember launcher for activity result, which is a composable function, and it will just make sure that the picker is registered in the correct lifecycle state. So just swapping this out should hopefully work. Let's relaunch this. Take a look here. There we go. Here's our contact, obviously, that does not have a photo saved. Let's create a new one. Pick an image, the image we just made, enter some data, some email, test at test.com. Whoops, and phone number 1, 2, 3, 4, 5, 6, 7, 8, 9. If we click save, then we do see the image. Yes, it's working. Obviously, we can't select it yet, but the image is saved. Also, if we relaunch this, we should hopefully see the image still. And yes, it works. Of course, if you want to take this to the next level, you could also use an image cropper, so you crop it to this squared format, but that would be way too much for this tutorial. And we're also not done yet, since we can click on contacts to open the contact detail sheet, and we also need to implement the recently added contact section. Let's do that next, but after that, we're done. So let's go to common main, contacts, presentation, components, and here we have our contact detail sheet. Make it a file, composable function, contact detail sheet. This will have an isOpen boolean. It will have a selected contact, which is a nullable contact, so the contact we just selected. It'll take an onEvent lambda as usual, takes in contact list events, turns unit, and an optional modifier as usual. In here, we're then going to use our bottom sheet from wish again. It's visible if isOpen is true. The modifier is just modifier. And here we're going to put our content for displaying a specific contact. And let's actually say we want to fill the max width of this modifier. And then here we're going to have a box for the same reason we had this in the AddContactSheet. Let's actually copy the content here and just remove everything we don't need. So just the box with everything in here, including the icon button. Paste this here and then just remove everything in here. The contact photo is needed. So let's leave that. I removed a little bit too much, I think. No, I didn't. Let's move the contact photo down. We remove this thing here, not including the spacer. So we just have our box with a column. We have our top spacing. Then we have our contact photo to display the contact's photo or just a placeholder where we need to pass our selected contact. This one here is not clickable since it's only clickable in edit mode. But other than that, we also have a sheet to an icon button to close the sheet, which is the same. So let's go on here and take a look at what we're going to build. It just popped up because I launched the other app here on my simulator. Let's click on a contact, and this is how it will look like. So we currently have this icon button to close the sheet. We already have this photo to show the photo, the contact's photo, or this placeholder. So now the next thing would be a little bit of spacing and the full name of the contact. And then this edit section, so we can edit and delete the contact. And then finally, these sections for displaying the phone number and email. Cool. So down here, let's first of all adjust this contact photo a little bit, since this time we're dealing with a very large photo. And just make sure that the icon size is 50 dp. So we just have a little bit larger placeholder icon. Down here, we're then going to have a spacer, modifier.height, 16 dp. And below that spacer, we will have our text. The text will be selected contact dot first name, actually nullable, and selected contact dot last name, like this. We then want to change the text appearance a little bit. On the one hand, the text align should be center. We then want to set the modifier to modifier fill max width. We want to say the font weight is bold, and want to say the font size is 30 SP, and Alt Enter to import SP. Then we can copy and paste this spacer, and now we need this added row. So just this row that I showed you here. So this here, these two icon buttons, I want to make that a separate composable down here. So private composable function called edit row. And this gets to lambdas on edit click and on delete click. Like this. It'll obviously be a row. Let's also pass a modifier here, just so that we could change it a little bit. Pass this to the row. And how do we now create these icon buttons here, since they are really just icon buttons but with a background? These are called filled tonal icon button in material 3. So we have one for on added click, which is the first one. Want to change the colors here. The colors are icon button defaults, filled icon filled tonal icon button colors to set the color scheme for the specific button. On the one hand, the container color, which is just our material theme, color scheme, secondary container again. And the content color is material theme, color scheme on secondary container. So with that, we just achieve that we have our color schemed button here. And then inside for the actual icon, we have a Jetpack Compose icon. The image vector is icons.rounded.edit. So the little pen icon, and the content description is just added contact. And we have the same for deleting a contact. This time we call on delete click. This time it's not the secondary container, because deleting is something kind of dangerous or destructive action. So we want to mark this in red, so in our error color. So this time we say error container and on error container. Here we want to say that is delete, and this would be, delete contact. Cool. Then we have our edit row, which you can use here. Edit row. On edit click will be selected contact.let. So if that exists, we want to call our on event with select contact. Is it called like that? Yes, with it. So the contact we want to select. And on delete click, in here, we just want to call on event with delete contact, which will delete the currently open contact if it exists. And then last but not least, we need these contact info sections. So with an icon at the start, the little title, and then the value, which is also separate composable, which I will create down here. pcomp. By the way, you probably won't have this shortcut here since I manually created that, but you can also use just normal comp and then make that a private composable. I call that contact info section. It'll have a title, it'll have a value, which would be the actual phone number, for example. It will have an icon in form of an image vector and an optional modifier. Cool. Then for that, we will also use a row. Should be obvious why. The modifier will be modifier, and the vertical alignment is just alignment.center vertically. So we just make sure everything is in order. Inside of this row, we want to start with our icon. So again, same concept as here, just that we don't have a clickable button. So we just use a normal icon. The image vector is our past icon. Content description is just null here. You could also pass this from the outside. I'll leave it for simplicity. And then we have a modifier. A modifier of modifier.clip. So I want to clip this to a circle shape, so a circular shaped icon. Then we want to assign a background color, which is our material, theme, color scheme, secondary container again. And we say we apply some padding of 8 dp. Last but not least, the tint, so the color of that icon should be material theme, color scheme on secondary container. So we again get the exact same look as for this edit icon. Then we want to have some horizontal spacing of a width of 16 dp. And then we're going to have a column, since we will display two texts on top of each other. The modifier of that column will be modifier.weight1f. And the vertical arrangement will be arrangement spaced by 8 dp. So what we achieved with these two values, on the one hand, with weight, we make sure that this icon gets the size it needs, but then the remaining space will be filled by this column here. And then spaced by 8 dp, we'll just make sure that we have 8 dp of spacing between these two texts. So inside here, the first text will be our title text. So title, modifier fill max width. The color will be material theme, color scheme secondary. So it's a little bit different color to not make it too prominent, because we want to make the value prominent, so the actual phone number or actual email. And the font size is also a little bit less than default, so 12 SP. And we then take this text, paste it below, have the same for our value. This time the color is on background, so it's more prominent, and the font size will also be larger to just make it stand out a little bit here. Then we can take this contact info section and use it below our added row. We can also add a spacer here again, and then let's have our contact. Not in caps, please. Contact info section. The title in this case would be phone number. The value would be selected contact.phone number, and otherwise just not existing, because we always have a phone number in this case. The icon will be icons rounded.phone, I guess, yes. And the modifier will be modifier fill max width. We can then take this, including the spacer, copy it, paste it below. This time it will be for our email address, selected contact.email. This time it's email, I guess, and modifier remains the same. This should be everything for our contact detail sheet, which we can now also apply in our contact list screen. Scrolling down to Add Contact Sheet, and right here, let's do it before we have a contact detail sheet. Is open, is state, is selected contact sheet open, selected contact is state selected contact, on event is on event, and the modifier is something we probably don't need. We also don't use one for the Add Contact Sheet. Okay, let's try this out by launching this on our Android device here. And we want to open this contact. Let's see, and it opens. That is looking perfectly fine. It is displaying all of our data, looking nice. If we close this, it does close. If we open one with a photo, then we also see the photo here, so looking pretty nice. If we want to edit this, then nothing is happening yet. We need to check that. If we delete a contact, I'm not sure if that works. Yes, that works. So deleting works. But let's take a look at why editing doesn't work by going into our contact detail sheet. Because if we click here in our on edit click, oh, actually, I actually called select contact. That should, of course, be added contact. And then that should also work. Let's quickly try this out again. If we open this, click edit, then yes, it will work just fine. We can edit our details. So Philip Lackner edited, for example. If we hit save, then this will also be updated here. We can see it, which works perfectly fine. You will see the null values just flashed up a little bit there. Once we hit save, or once we click edit rather here, which you could also potentially bypass with a simple delay or waiting until the first sheet closed and then showing the second one, which probably doesn't harm user experience, but would solve this little visual issue here. I also won't deal with this here just for the sake of simplicity, and we're already a lot of time in here. But last but not least, we want to create our recently added contact section. And that will be very quick since we have the necessary composals for that already. We just want to create a contact preview item, which is a normal file, contact preview item. And this will just be here, this section. So such an item, but since we already have the photo composable, we just need to put that on top of the first name of that contact. Here we want to display that for a specific contact. We want to have an on-click, a lambda, and we want to have a modifier, which is the default modifier by default. Then let's have a column, as I said. We pass the modifier. We then want to have this as a clickable modifier where we pass our on-click lambda. We want to set the horizontal alignment to alignment.center horizontally. And in here in this column scope, we can then have our contact photo. The contact is our contact we passed. Modifier is modifier.size 50 dp. And then below, we're going to have a little spacer with a height of 8 dp. And last but not least, our text for the contact's first name is contact.firstname. That's it for our contact preview item. Now let's have our recently added contact section in here in presentation components. Recently added contact section, or recently added contacts. Let's leave it like that. Composable, recently added contacts like this. In here, we're going to have our contact list, which is a list of contacts. Surprise. We're going to have an on-click lambda. When we click on a specific contact, we want to pass this contact to the parent composable. And we're going to use a modifier as usual, which is the default modifier. In here, what does this list consist of? In the end, we're just going to have this title text recently added, followed by a lazy row with all of our recently added contacts. In here, we have our column. Since we want to display the title text on top of our lazy row, so we have a column, pass in our modifier, and if our contacts is not empty, so if there are recently added contacts, then we want to show the title text is recently added with a capital A. The modifier for this text will be modifier fillmax with dot padding, only horizontal padding with 16 dp, Alt Enter, and below we want, actually let's also put in a font weight, bold, and below this text we're going to have our lazy row. Modifier is modifier fillmax width. The content padding is padding values of horizontal 16 dp. And I want to add some spacing horizontally. So horizontal arrangement is arrangement that spaced by 16 dp. So we just have 60 dp of spacing between each contact here. And inside of this lazy row, we're going to have an items block. Make sure to choose the one with a list, which takes in our contacts, gives us each contact here individually, and we can then create a contact preview item with that contact. So contact is contact, and on click is on contact, or actually on click here, where we pass in the contact we clicked on. Now we're going to take this composable and call it in our contact list screen. Going up to the very start of our lazy column, item recently added contacts. The contacts come from our state, recently added contacts. On click would be on event, select contact with the contact we clicked on. And I guess that is it. Let's try this out. I think this should be everything of this app. So want to try this out here. There we go. The app is launching. And we do see this contact here. We just need a little bit of spacing between the title and this. But if we click on this, then we still get to see the added contact section the same as here. Cool. Very cool. If we take a look here in our contact, not detail sheet, actually, what did we just implement? Recently added contacts. Here, we just want to add some spacing. So spacer, modifier height, 16 dp. I would say we launched this on iOS as well. Select iOS contacts MP. I'll launch this, and I am very curious if this will now also work on iOS. Nope, it doesn't. Build iOS application failed for whatever reason. Android Studio usually doesn't give us many errors. Maybe we just need to go into Xcode and build it there. Take a look here. What if we launch it from here? Here it also tells us build failed. Not sure why. I might need to look into that and then get back to you when I fixed it. So there was actually no error. I just needed to rebuild the project. You will probably notice that there's still an error when you rebuild it, which is something like this, illegal state exception. This is something you seem to currently just get when you rebuild KMM projects with the current version of Android Studio. But you can ignore this because your app will still compile and launch, which I've now done here. So this is now the up-to-date iOS app. Let's click on Add a Contact, because right now there's no recently added contact section since we don't have any contact, obviously. Let's add one. Let's add a photo. Take a look here. We can also check if saving a photo works. Let's select that one. Create a contact. Something like this. Test. Oops. Test. That is something I've noticed, that if we go back in iOS text fields, then it often removes more than just one character. I don't know if that is a bug of Compose Multiplatform or something of the simulator here, but that is a bit weird. Let's ignore that and choose a phone number, save. And yes, our image saving works. We see our recently added section. We can hopefully select a contact. We can edit it. We can say edit. We should also be able to pick a different image right here. Click save. And there we go. We saved it. Finally, deleting a contact should also work If we click the delete icon, yes, that one's gone. So that is how you create a Compose multi-platform contacts list app with CRUD operations. So creating contacts, deleting them, editing them, and of course just retrieving them. Before you go, I got a little gift for you. Since we've dealt so much time here with building UI with Jetpack Compose, which is absolutely great for building UI as you've seen, but there are just so many deadly traps you can step into. You can really do a lot wrong with Jetpack Compose. And I still see it as the future of UI development on mobile, but to help you to avoid these mistakes and these traps, I've written down 20 things you should really never do with Jetpack Compose, and I've combined it into one single PDF, which you can now get completely for free. So this is really not just a list where I say, hey, there's a mistake, there's a mistake, there's a mistake. Every single mistake really gets its own page. I included code snippets that show you what's wrong and how to actually fix that issue with a detailed explanation. So every single mistake gets its own PDF page. The whole thing is longer than 20 pages, and you can really use that to, on the one hand, check your current projects that use Compose if you do any of these mistakes, or also use it to just learn about these mistakes to not do them in future. So if you want to get that completely for free, check the link in this video's description and you will get the PDF via email. And other than that, I have to say thank you for watching this video for this long. If you did it this long, then you're definitely serious with Android development, because these videos, which are 2, 3, 4 hours long, usually have an average watch time of 7 minutes or so, which I think is a little bit sad, given the fact that you can just watch this completely for free. But if you reach this point, then congratulations. I hope you learned a lot and I hope you enjoyed this course. I would definitely love some feedback below. Also, if you think a certain thing wasn't explained that well or so, that just helps me to improve my way of explaining and make even better videos in future. So thanks a lot for watching this far. I will see you back in the next video. Wish you an amazing rest of your week. Bye bye.